Hello and welcome. Today we're diving into artificial intelligence and its inner workings, from theory to concepts to examples. You hear about AI almost on a daily basis. Everybody is speaking about AI, on the news, in social media, at work. Some people use it to help them with different tasks, and a smaller group of people actually understand AI. They know what it means and how you get it to work. Which group do you want to belong to? If you look at this image and you want to be part of the turquoise smaller circle, you've come to the right place. Whether you are curious how AI can help your team or your company and you want to know what it means to implement AI in production, or you are just curious to discover what's behind the surface of the most posh technology, this course is perfect for you. Don't worry, you don't have to understand code to follow the lessons. Here's a quick overview of the course. We'll cover key AI concepts and terminology. Not only this, but you will also discover the how behind them. What are the steps that a data scientist and an AI engineer take to prepare a machine learning model? We'll stop to explore object detection and NLP, and we'll move our focus to generative AI and prompt engineering. You will discover so many useful tools and use cases where you can apply AI in your daily life and at work. Theory only will not answer your question on how to integrate AI in production. To answer it, we will talk about deployments through an API and cloud services. We will end with a discussion on AI ethics. Responsible AI is not a nice-to-have. It's a necessity and a responsibility for everybody adopting AI. While we progress through the lessons, we'll explore fascinating real-world examples to ensure you leave with a strong understanding of the topics. But first, a little bit about me. I'm Adela, and I'm excited to be here with you today. I've spent over 10 years working in artificial intelligence development, specializing in machine learning applications across different industries, like navigation, e-commerce, and banking. I've been on both sides, developing and managing, so I truly understand what it takes to bridge the gap between AI theory and real-world implementation. Throughout my career, I've had the privilege of leading innovative projects and contributing to the field. I saw AI going from just a concept into a powerful and impactful production system. My mission? To make AI practical and accessible, helping professionals just like you to fully understand AI, and even more, not just understand it, but actually apply it in their work. I look forward to sharing my expertise with you as we explore AI together. Here's a quick look at the first 4 modules of the program. We'll start by covering the foundational topics and key concepts, so the next time when you hear about supervised learning, unsupervised, reinforcement learning, neural networks, and deep learning, you'll know exactly what they mean. Not only this, but you will also discover the how behind them, with some concrete examples for supervised and unsupervised learning. As we move to the next modules, we'll discover more complex AI areas like computer vision and NLP. We'll spend a significant time focusing on generative AI, where we will explore different generative AI options, going beyond simply using ChatGPT for text generation, but also for images, audio, and video. With some tips and tricks on prompt engineering, you will learn how to get the best results out of AI. As theory and production are 2 different worlds, we'll explore how we can expose our models through an API, and we'll move on to explore the cloud, as concept and as offer for AI services. By the end of Module 8, you'll have gained a strong understanding of what it means to apply ethical AI, such a necessary step when considering AI. Whether you're completely new to technology and simply curious about AI, or you are a professional that wants to understand how you can benefit from it, you're in the right place. By the end of this course, you'll feel confident talking about AI, understanding its applications, and recognizing its implications in the modern world. Let's start the first lesson. Now, let's start with the basics. What is artificial intelligence? In simple terms, AI refers to the simulation of human intelligence in machines. These systems are designed to learn, reason, and solve problems, much like humans do. Think about some common AI-powered technologies you may already use in your daily life. Voice assistants like Siri or Alexa, which recognize and process speech. Google Translate, which helps with translations. Or even your phone's camera, which can identify objects and people in photos. But AI is not a single technology. You have probably heard about different terms. Artificial intelligence or AI, machine learning or ML, deep learning, generative AI or GenAI, data science, and more. Are they all the same? Are they different? And if so, what's the difference? Let's break down some key concepts. Artificial intelligence or AI, the umbrella term for systems that simulate human intelligence, systems that learn to solve problems like humans. Machine learning, or ML, is a subset of AI that involves the development of algorithms and statistical models, enabling computers to perform tasks without explicit instructions. Instead, these systems learn from data, identify patterns, and make decisions with minimal human intervention. Deep learning, a subset of ML that uses neural networks with multiple layers imitating the human brain to model and understand patterns in complex data, such as recognizing faces and images. Generative AI, or simply called GenAI, a branch of AI focused on creating new content. Some tools generate human-like text, while others are developed to create realistic images or even compose music. Unlike traditional AI systems that primarily focus on recognizing patterns or making predictions based on existing data, GenAI models are used to generate new content. LLMs are a specific type of generative AI model trained on massive amounts of text data to understand and generate human-like text. Think of it this way. All LLMs are generative AI, but not all generative AI models are LLMs. Generative AI is like a toolbox with tools for generating text, images, music, and videos. LLMs are one specific tool in that box, designed for tasks related to understanding and producing text. Data science, the practice of extracting insights and meaning from data using scientific methods. Data science is like being a detective for data. Imagine you have a huge pile of information, like numbers, text, or pictures, and your job is to find patterns, answers, or useful insights in that pile. You use tools like math, statistics, and computer programs to analyze the data and figure out things like what happened, looking at the past, what might happen, making predictions, how can we make things better, solving problems. For example, a data scientist might look at shopping habits to help a store suggest what you might want to buy next. Or they could analyze weather patterns to predict when it will rain. In short, data science is about turning messy data into valuable knowledge. By understanding these terms, you'll be able to navigate the AI landscape confidently and see how each concept fits into the bigger picture. Congrats on finishing the first lesson. Congrats for having the drive to learn something new. You'll love the improved you. Let's recap a little bit. What is AI? AI refers to the simulation of human intelligence in machines that are designed to learn to solve problems like humans. Key terms include artificial intelligence, machine learning, deep learning, generative AI, LLM, and data science. In the next lesson, we will look at history of AI, and next at the machine learning process, discover different types of machine learning techniques and learn key terminology. To truly understand where we are today with artificial intelligence, it's important to take a step back and explore how it all began. The history of AI is a fascinating story of ideas, breakthroughs, setbacks, and revolutionary progress. It's a journey that spans decades, from the first concepts of thinking machines to today's powerful AI systems that drive industries. So how did it start? In 1642, we have the first mechanical calculating machine built by French mathematician Blaise Pascal. In 1837, Ada Lovelace was the first to recognize that the machine had applications beyond pure calculation. Ada Lovelace is now considered by many to be the first computer programmer. She had a long working relationship and friendship with Charles Babbage, who is known as the father of computers. She was in particular interested in Babbage's work on the analytical engine. Her work on his proposed mechanical general-purpose computer included elaborate notes, one of which contained what many consider to be the first computer program. That is, an algorithm designed to be carried out by a machine. The concept of thinking machines dates back to the 1950s. In 1950, Alan Turing, a British mathematician, asked the fundamental question, can machines think? He proposed the Turing test, a measure of a machine's ability to exhibit intelligent behavior indistinguishable from a human. The term artificial intelligence was first used in 1955, and by the 1960s, we saw the emergence of natural language processing. Imagine this era. Computers were massive machines with limited power, yet scientists dreamed of building machines that could think like us. Despite early optimism, progress slowed due to limitations in computational power and the inability to scale AI systems. AI faced significant challenges in the following decades, a period often referred to as the AI winter during the 1970s to 1980s. Every major technological innovation has faced challenges. AI was no exception, but the seeds of future breakthroughs were already being planted. Researchers shifted focus from programming rules to enabling machines to learn from data. In 1997, IBM's Deep Blue defeats chess champion Garry Kasparov. For the first time, a machine defeated a human world champion in chess, showcasing the power of AI. 2009, first self-driving car. Google builds the first self-driving car to handle urban conditions. 2012. Breakthrough with neural networks. AlexNet, a deep neural network, won the ImageNet competition, significantly outperforming traditional methods in image recognition. This milestone sparked the deep learning revolution powered by advancements in hardware, particularly GPUs. 2015. Deep reinforcement systems like AlphaGo defeated human champions in Go, a game far more complex than chess. Deep learning opened the floodgates. Suddenly, AI could see, hear, and generate, ushering in a new wave of AI applications. 2020s. Generative AI domination. In 2020, GPT-3 was released. OpenAI's generative pre-trained transformer revolutionized natural language processing, generating human-like text. From early dreams of thinking machines in the 1950s to today's generative AI models creating text, images, and even music, the history of AI is a testament to human ingenuity and perseverance. Nowadays, everybody speaks about AI, and most universities have introduced courses on artificial intelligence. We stand on the edge of an exciting AI future where innovation continues to accelerate. As you move through this course, keep this history in mind. Every AI tool we use today is built on decades of breakthroughs, failures, and learning, just like your own journey into AI will be. In this lesson, we'll explore how machine learning differs from traditional programming, uncover the core principles behind how machines learn, and discover the different types of machine learning. Traditional programming involves humans writing explicit instructions and rules that a machine follows step by step. However, with machine learning, the process is different. Instead of coding all the rules, the machine learns patterns and rules from data to make predictions or decisions on its own. With traditional programming, the process is as follows. Humans write explicit instructions code for a machine to follow. We have as input rules plus data, leading to an output. For example, writing an algorithm to calculate tax based on predefined rules. With machine learning, on the other hand, the process is different. The machine learns patterns and rules from data to make predictions or decisions. We have as input just the data, leaving it to the machine model to learn the rules that can be applied for new decisions or predictions. For example, feeding a model transaction data to learn patterns and detect fraud. Think about a task like spam detection. How many explicit rules would you need to write to cover every possible spam email? This is why machine learning is so powerful. It scales where traditional programming cannot. This shift from predefined instructions to data-driven learning is what makes machine learning so powerful, enabling applications like spam detection, image recognition, and even self-driving cars. Machine learning can be divided into three main types: supervised learning, unsupervised learning, and reinforcement learning. Each type is designed to address different types of problems, and we'll explore examples to make these concepts clear. In supervised learning, the model learns from examples where the correct answers are already known. For instance, imagine we have a data set of fruit images that are labeled as either apple or banana. The model learns to identify the patterns that distinguish apples from bananas. So when we show it a new image, it can correctly predict whether it's an apple or a banana. In unsupervised learning, the model doesn't have predefined answers to guide it. Instead, it finds patterns or structures in the data on its own. For example, if we give the model a collection of fruit images without specifying which ones are apples or bananas, it might group the images into clusters based on their similarities, like color or shape, without needing explicit examples or labels. Reinforcement learning works differently. Here, the model, or agent, learns through trial and error in an environment. For example, imagine a video game where an agent controls a character. The agent is rewarded for reaching the goal, for example, finding the piece of cake, and penalized for falling into traps. Over time, it learns the best strategies to win the game by maximizing rewards and avoiding penalties. These three types form the building blocks of machine learning, and we'll see how they're applied in various scenarios throughout the next lessons. In machine learning, there are some key terms that are widely used, and I will use them throughout this course. Let's take them one by one and clarify them. Train. Training is the process of teaching a model to recognize patterns in data. Imagine we're building a machine learning system to predict whether an email is spam or not and categorize it accordingly. The process of preparing the machine learning model, starting with the dataset, and generating the machine learning model that has learned the rules on how to differentiate spam and not spam, is called training. Model. The model is the result of the training process. It's a mathematical representation of the patterns found in the data. In our spam filter example, the model learns what characteristics, like specific keywords or unusual email addresses, are associated with spam email and represents them as numbers. Don't worry. We will discuss this process later on in the course to understand how you go from text to numbers. A label is the correct answer provided during training. For the spam filter, the labels are either spam or not spam, indicating whether each email in the training data that was used to teach the model examples is a spam email or not. When we talk about labeled data, we talk about both the input data and the correct labels. For example, we want to train a machine learning model to predict if it will rain or not. To do this, we may start with a dataset that might have rows of information like temperature and humidity and others, the input, and whether it rained, the label. Think about how you'd teach a child to recognize a cat. You'd show them lots of labeled pictures of cats and say, "This is a cat." That's essentially what labeled data does for machine learning. Machine learning is like a baby learning about the world. It simply knows what he is taught. Moving on, we must talk about what we call features. Features are the individual pieces of information the model uses to make predictions. In the weather example, features might include temperature, humidity, and wind speed. If we train other models, other information is more relevant. Let's say we want to predict house prices. In this case, features could include size, location, number of bedrooms, and age of the property. Basically, features is the relevant information used to train machine learning models. For images, features are the information behind the pixels in the image. More on this in a future lesson. Think of features like a column in a spreadsheet and a label if the final answer you're predicting. Predict. Prediction is when the trained model uses new, unseen data to make decisions. For instance, the house detection model sets a selling price for a new house. Great. Now you know the language. These terms, train, model, label, labeled data, feature, and predict, are the building blocks of machine learning. By understanding them, you'll gain a solid foundation as we dive deeper into the world of artificial intelligence and discover one by one the different mechanisms with hands-on examples of training a machine learning model. We'll take it step by step. In this lesson, we'll have an overview of the different types of machine learning, and you can see how we use this terminology. Now, let's take a look at supervised learning, one of the main types of machine learning. In supervised learning, the key idea is to train a model using labeled data. The model learns by looking at input data along with the correct answers, or labels, to understand patterns. Once trained, it can make predictions on new, unseen data. Let's break it down with an example. Imagine we're training a model to detect spam emails. We provide it with a data set of emails, where each email is labeled as either spam or not spam. By analyzing these labeled examples, the model learns to recognize patterns like certain words, email structures, or sender addresses that are common in spam emails. Once trained, the model can predict whether a new email is spam or not. Another example of supervised learning is image recognition. For instance, we could train a model using a data set of images with apples and bananas, where each image is labeled to indicate which fruit it contains. An image can have an apple, as well as a banana, and a rectangle is drawn during the labeling phase around each fruit. After training, the model can specify whether a new image contains an apple or a banana, and identify it in the image. That's it. Got the idea? Supervised learning is widely used in many fields, and it's a powerful tool for solving problems where we have labeled data available. If we were to summarize supervised learning, we would do it in 2 steps: train and predict. During the train step, we teach the model using labeled data. This data contains inputs, called features, and the corresponding correct outputs, called labels. The model learns the relationship between them, creating a mathematical representation of the patterns in the data. For example, in a spam detection system, the model is trained using emails labeled as spam or not spam, learning the patterns that differentiate the two. Once the model is trained, it can be used to make predictions on new, unseen data during the predict step. To do this, it uses the previously trained machine learning model to generate an output. In our example, if we have a new email, we can use the previously trained spam detection machine learning model, and it will analyze the features of the email and predict whether it's a spam or not. Let's move on to unsupervised learning, another key type of machine learning. Unlike supervised learning, unsupervised learning learns patterns and structures from data on its own without explicit labeled data or specific guidance. For example, in a fraud detection use case, by analyzing transaction data, the model can identify unusual patterns or behaviors, such as sudden large purchases or transactions from new locations, even without being explicitly told what constitutes fraud. One more use case is customer purchasing behavior. Imagine we have a data set of customer purchasing behavior, but we don't know any specific details about the customers. An unsupervised learning model might group these customers into clusters based on their shopping habits. One cluster might represent frequent buyers, while another might group customers who shop only during sales. Another common application is principal component analysis, or PCA, which reduces the number of features in a dataset while preserving as much information as possible. This is particularly useful for simplifying complex datasets and an easier data visualization. In summary, unsupervised learning is about exploring the hidden structure of data, making it a powerful tool for discovering insights where no labeled data is available. Now, let's talk about reinforcement learning, or RL, the third type of machine learning. Have you ever trained a pet using treats? That's reinforcement learning in action. The pet repeats the behavior that gets them the reward. Reinforcement learning is inspired by how humans and animals learn from their environment through trial and error. In this approach, an agent, a decision-maker system, or learner interacts with its environment, takes actions, and learns by receiving feedback in the form of rewards or penalties. It is rewarded for correct moves and penalized for the wrong ones. In doing so, the agent tries to minimize wrong moves and maximize the right ones. The goal of the agent is to maximize the total rewards over time. For example, in a video game, reinforcement learning is used to train agents that optimize their strategies to win, such as learning when to attack or defend in a game. Reinforcement learning is also used in real-world applications, like self-driving cars. The car, as an agent, learns to make decisions like staying in a lane or avoiding obstacles, based on feedback from its sensors and the environment. This type of learning is especially powerful for tasks that require a sequence of decisions and adaptability to changing environments. As a summary, machine learning is very similar to a kid learning about the world or a dog learning new tricks. We have supervised learning. Think of this like teaching a child learning the alphabet. You show the child pictures of the different letters. This is an A, this is an D. With enough examples, the child learns to identify the letters on their own. In machine learning, this is like training a model with labeled data to make predictions. There is unsupervised learning, which is more like letting the child play in a field full of flowers without any instructions. The child starts to notice patterns on their own, like grouping all the small purple pansies on one side and the yellow dandelions in another pile. In machine learning, when using unsupervised learning, the model identifies patterns or clusters without needing labels. Reinforcement learning works like training a dog with rewards and punishments. Imagine teaching the dog to sit. Each time it sits correctly, you reward it with a treat. If it jumps instead, you don't give a treat. Over time, the dog learns to maximize the rewards by sitting when you command. In machine learning, the agent learns by interacting with its environment and receiving feedback, maximizing reward. In short, supervised learning is like teaching with guidance. Unsupervised learning is discovering without instruction, and reinforcement learning is learning through trial and error. Just like kids learn by example and dogs learn through rewards, machine learning models learn by either being shown labeled data, discovering patterns on their own, or adapting their behavior based on feedback, making the process remarkably similar to how we teach and train in everyday life. Let's summarize what we've learned in this lesson about machine learning. First, we compared traditional programming and machine learning. Traditional programming relies on explicitly defined rules, while machine learning allows systems to learn patterns from data and make predictions. We introduced key terms like train, model, label, labeled data, feature, and predict, which are fundamental to understanding machine learning. Then, we explored the three main types of machine learning: supervised learning, where models are trained using labeled data to predict outcomes, for example, in a spam detection model; unsupervised learning, which identifies hidden patterns or groups in data without labeled responses. Examples include customer segmentation and fraud detection; reinforcement learning, where agents learn by receiving feedback from actions, either rewards or penalties, while interacting with their environment. Examples include video game strategies and self-driving cars. In the next lesson, we will look at some more machine learning usages in the real world and slowly progressing to more advanced topics. We've explored some examples in the previous lessons. Let's have a look at some more use cases from the real world, where machine learning is used to make a difference. Digital assistants like Siri, Alexa, and Google Assistant help us with everyday tasks, such as setting reminders, searching the web, or controlling smart devices, all powered by AI. Recommendation systems. Platforms like Netflix, Spotify, and Amazon use artificial intelligence to suggest movies, songs, and products based on your preferences, ensuring a personalized user experience. Healthcare. In the medical field, AI assists in diagnostics by analyzing medical images to detect abnormalities, helping doctors make faster and more accurate decisions. Chatbots. Customer service has been revolutionized by GenAI-based chatbots, which provide personalized and human-like interactions, enhancing user experience across industries and freeing time for the call center employees, taking away simple, repetitive tasks and leaving more room for the complex ones. Personalization in marketing. Generative AI enables marketers to create personalized advertisements and emails, boosting speed and effectiveness. In automotive, artificial intelligence drives innovation in assisted driving, self-driving cars, object detection, and more, making transportation smarter and safer. In the financial sector, artificial intelligence helps with anti-money laundering, calculating the risk score, fraud detection, and more, safeguarding transactions and ensuring compliance. All of the examples presented above are just a sublist of all the different use cases where machine learning can be used in these domains. There are many more examples in the same domain and many more other areas where AI can be used. In my personal professional experience, I have worked on projects that used artificial intelligence in automotive to detect road geometries and to correctly predict navigation elements. In an e-commerce scenario, we've used it to enhance the search relevancy and recommend products and connected categories. In banking, for automating the garnishments calculation, cluster call center emails to understand key complaints and demands, onboarding scenarios, ID card identification, face comparison and liveness detection, automatic information extraction from documents, building digital assistants based on internal documents using GenAI, and the list goes on. By combining different types of machine learning, supervised, unsupervised, and reinforcement learning, AI systems are able to perform complex tasks and adapt to user needs, often without us even noticing their presence. As you could see in these examples, AI is widely spread and integrated into many products that we use today, ranging across all industries. On one side, we use AI to help make our company's operations more efficient, and on the other, it helps us implement new ideas that were not possible before AI, opening new, previously uncharted domains. You saw some examples. Now, let's get to work. In the next lessons, we will start with concrete implementations in Python so that you can discover how you can implement artificial intelligence in your projects. Introduction to Kaggle. Why am I starting with Kaggle? Simple, because it is an important resource to get started with AI. I don't want for you to simply browse through this course. I want to give you the tools and the means to really apply AI after the completion of this course. Kaggle has some important features that I want to explore together with you. Quite a helpful resource, I would say. This is an interesting part of Kaggle. Here, companies and researchers post real-world AI challenges where people can compete for prizes or just for fun. Some competitions are presented by companies that want to solve a problem and offer that as a competition. The project with the best results wins the money. Maybe one day, you can advance so much in AI that you are one of those winning teams. But the interesting part about competitions is not this one. It is a valuable learning resource. Once they are finished, they still remain visible and you can see past submissions. Some competitions are simply with the purpose of learning something, and they can be extremely helpful for you to try your hand at something. You have a data set, a problem, and you can also see how others performed. I mentioned data sets. Besides these competitions, you can also find standalone datasets for various scenarios, from getting started datasets like the Titanic passengers or Melbourne house prices that are two examples of key learning materials when starting with AI. We also have hand gesture datasets, blood cell images for cancer, investment trades datasets, and the list goes on. You want to try a new idea implementation? Go check out Kaggle for a dataset that you could use. The majority of these datasets have an open license, and you can use them in your projects without any constraints. This section is like a treasure chest filled with tons of free datasets for AI projects. If you need data to practice AI, this is the place to find it. You can search for datasets, preview data before downloading, download or use it directly in Kaggle notebooks. You can even filter datasets by topic, file type, size, attributes, etc. To download them, you would need an account, but that is free of charge. Notebooks. So what are those? A Kaggle notebook is like a digital notebook where you can write Python code for AI and machine learning, run code on powerful cloud computers, use pre-installed AI libraries like TensorFlow, PyTorch, Pandas, and scikit-learn. More on them in the following lessons. Store and access datasets easily without downloading them. Share your work with others or collaborate on projects. For example, if you want to train an AI to recognize handwritten digits, but you don't know how to start, you can go discover existing datasets for that, run it using some GPUs, have a look at some existing codes that make use of this dataset for inspiration, or use an existing model and integrated it into your app. Pre-existing model? Yes. You can go check out if someone else has created a model for your use case that you can use. In Kaggle, you can find custom models for a particular use case, as well as general-purpose models. You can often find an existing model linked to a particular use case. My suggestion? Go and explore Kaggle. It is really a tremendous help when starting with AI. Okay, let's explore Kaggle. We go to Datasets to find a dataset. You can either select one that you've previously used and go directly to that, or you can go in Datasets and search for something, scroll, browse around, see what you find. You can filter based on text, size, and so on, or search by keywords, let's say hand gesture datasets. We have here 213 datasets with hand gestures in them. We can also look for the Titanic disaster dataset. People can start with the one dataset and present it later in different forms. We can create a new notebook that uses this dataset. It takes a little bit to start. And now we have the first cell in the notebook. We can add cells. You can add code here. Let's say that we want to print something like, hello. Oh, my typing is terrible today. You run the cell. It takes a little bit to warm up. We wait a little bit. You can see that it's starting, but once it starts, it's going to say running, and it ran. You run all cells with this Run All Cells button. To change the GPUs, you go to Settings Accelerator and you select the GPU that you want to use. You can turn it on. You have 30 hours per week. I've already used one today, but I'm not going to do that because I want to show you the other features as well. We go to Code, for example, if you want to explore other notebooks, let's say one on Titanic. Let's pick one. Maybe this one with beginner name, and then you can go and look at the notebook that was created, or you can go and edit your version. I'm going to edit my copy here. Just wait a little bit for it to start, and you can see the cells of the notebook, and you can interact with it here. Pretty great, no? Now, I want you to stop this lesson. Stop and go and explore Kaggle. I'm waiting. That is great. Let's move on and learn how to implement it. The most used programming language for building machine learning models is Python. We will go briefly over an example so that you have a better idea of what it implies to build one. I will show bits of code so that you can form an idea of what it means to prepare a model. I will not go into the details. Don't worry if you don't understand the code. That is not the point. The idea is to get a glimpse of the world of data scientists working on a machine learning model. If you find this too technical, you can skip to the next module. If you're curious about the steps and reasoning that goes behind such a machine learning model, well, this is it. First, we start with data preparation, and then we move on to building the model. All right, let's dive into supervised learning and model building. This must be exciting. Your very first machine learning model, and we are just getting started. A little bit of recap. In supervised learning, we start with labeled data, where we have both features and labels. The training process helps the machine learning model learn from these labeled examples. Once trained, the model is ready to handle new, unseen data, make predictions, and give us useful outputs. For example, I have here a notebook called Supervised Learning. I wonder what will be in it. Let's go together over this notebook. First, we need to install the required modules. Once the cell runs successfully, the libraries will be installed. We can look at an example using the Titanic dataset. This dataset gives information about people on Titanic and whether they survived or not. It is kind of an introduction model when learning about AI. We want to build a machine learning model that predicts if a person would have survived or not based on some information about that person and journey. The Titanic dataset, we have a passenger ID. If he or she survived, the ticket class, person's name, sex, age, number of siblings and spouses on board, number of parents and children, ticket number, the fare price for the ticket, cabin number, and the embarkation port. We will look at the operations and the reasoning behind feature engineering, or simply put, how do we prepare the data for machine learning? Now, let's get into feature engineering, the process of preparing data to improve model performance. This includes feature creation, the process of generating new features. Sometimes we can use the data at hand and transform it a little bit to get to better features. Feature transformation and imputation. First, we need to deal with missing values. Many ML models cannot handle missing values, hence we need to either remove them or replace them. Next, we move on to prepare the data to be better suitable for ML models. ML models work with numbers only, hence we need to convert categorical features and we transform the data accordingly. We do normalization, standardization, and logarithmic scaling. We will explore them in more detail shortly. Moving on to feature extraction. For high-dimensional data, we should remove the number of features. It is not really the case for our Titanic data, but you should know about this. The last step is feature selection. Not all data from the input should be used to get the desired output result. We must pick the most relevant features only. How to do all of these? We'll get practical in a Python example. By preparing our data properly, we ensure the model gets high-quality input, leading to better predictions. Feature engineering. Let's look at a concrete example in our use case. First step, feature creation. In this example, we are creating a new feature in our dataset called young. This feature will indicate whether a passenger is younger than 12 years old. Now, let's introduce an important concept in data preprocessing called feature binning. Binning is a technique that allows us to group continuous values into discrete categories, making it easier to analyze and use in machine learning models. In this cell, we are applying binning to the age column in our dataset. Since age is a continuous numerical value, we want to categorize passengers into different age groups, such as small child, teenager, and so on. Let's go step by step through the code. First, we define the bins using a list. Each number represents the boundary of an age group. 0 to 5 represents small children. 6 to 12 represents older children. 13 to 18 represents teenagers. 19 to 35 represents young adults. 36 to 65 represents middle-aged adults. 66 to 120 represents senior passengers. Next, we define labels for these age groups. These labels correspond to the bins we defined earlier, allowing us to assign meaningful names to each group. Finally, we use the cut function to create a new column in our dataset. This results in a new column called age group, where each passenger's age is categorized into one of the 6 defined groups. Feature binning helps us make the data more structured. Great. Now that we have categorized the age values into different groups, let's take a look at how the data has changed. In this step, we display a small portion of our dataset to check if the new age group column has been created correctly. This helps us verify that the binning process worked as expected. When we look at the output, we should see that each passenger's age is now assigned to a specific category. If the column is correctly filled, it means our feature binning worked successfully. For example, passenger ID 1 has age 22 and age group young adult. Correct. Next, age 38 has age group middle-aged. Correct? Everything looks good. Moving on to the next step in our analysis. Let's talk about an important step in data preprocessing: handling missing values. Missing values occur when some entries in our dataset are left blank or unavailable. This is common in real-world data and needs to be addressed before using the dataset in a machine learning model. If we don't handle missing values properly, they can negatively impact our analysis and model generation. In this step, we are checking which columns in our dataset contain missing values. To do this, we use the info function that counts how many non-missing values are present in each column. The output will help us see if any features have incomplete data. We can see that we had 891 entries in our dataset. Out of that, for age column, we only have 714 value, same for age group, of course. For cabin, there are only 204 entries and the rest look good. Once we identify the columns with missing values, we need to decide how to handle them. We need to take action to fix these missing values. We can use the fillna function. For example, if the cabin column has missing values, they are filled with the word unknown. After running the cell, we can see several unknown values here in the output. For all rows that did not have a cabin value, now they say unknown. We can also replace a missing value looking at the data already present. For example, replacing missing values with the median is often a better approach than using a default value. As a reminder, the median is the middle value in a sorted dataset. In this case, we are focusing on the age column. Looking at the output, we see that the median age is 28. This means that half of the passengers are younger than 28, while the other half are older. We can use this median value to replace the missing age values with this median. We can also set for the missing age group the default to be young adult, as this would be the corresponding category for 28 years old as the median value. Let's check it out. We look at the previous cell output for a missing age. For example, this passenger with ID 889. After the fill N or A, one cell below, we have now age 28 and young adult for the age group. The replacement worked. Good on us. Many machine learning models work best with numerical data. Or better said, they cannot work with text values or categorical data. So we need a way to transform these features into numbers while preserving their meaning. There are three main methods for transforming categorical variables. 1. Hot encoding, label encoding, and ordinal encoding. Let's explore each of them. 1. Hot encoding. 1. Hot encoding creates separate binary columns for each category. Each new column represents whether a category is present, using 1 for yes and 0 for no. This method is best suited for non-ordinal categorical variables, meaning categories that do not have a natural order, such as gender, sections, or cities. However, 1 hot encoding can create too many columns if the categorical variable has a large number of unique values. This can make models more complex and harder to train. Label encoding. Label encoding assigns each unique category an integer value starting from 0 and increasing for each new category. First value gets assigned 0. Second distinct value gets the value 1, and so on. This method is useful when we want to avoid increasing the number of columns, making it efficient for large datasets. It is also commonly used for target variables, such as predicting whether an email is spam or not. On the con side, label encoding introduces an order where there is none. If the encoded values are interpreted as having a ranking, it may influence the model incorrectly. Ordinal encoding. Ordinal encoding is similar to label encoding, but is specifically used when categories have a defined order. It assigns integer values while respecting a logical sequence. By default, it uses the order in which it finds the values, but you can also specify a predefined list of ordered values. Similar to label encoder, ordinal encoder keeps the same number of columns but can also introduce an order. For example, if we are encoding the text first, second, third, we could use the logical order, or for temperatures, we can order them from cold, warm, and hot. This method ensures that the order is preserved, making it useful for categorical variables that have a hierarchy. However, similar to label encoding, without an explicit order, ordinal encoding can still create an unintended order. If the categories do not truly have a ranking, the model might treat them as such and make incorrect predictions. Great. Now that we understand categorical encoding, let's see them in practice. How to put them in practice? Like this. Remember, 1 hot encoding works by creating new binary columns for each unique category in a given feature. Each of these columns represents whether a particular category is present in a row, using 1 for yes and 0 for no. Let's take an example from our dataset. The sex column contains 2 categories, male and female. Hot encoding will create 2 new columns. 1 column for male, sex male, which is 1 if the person is male and 0 otherwise. 1 column for female, sex female, which is 1 if the person is female and 0 otherwise. You can infer one from the other, hence you don't need one. Drop first equals true attribute removes the column corresponding to the first value. The same process is applied to the embarked column, which contains 3 unique values, S, C, and Q. 1 hot encoding will generate 3 separate columns. Embarked C for passengers who embarked at port C. Embarked Q for passengers who embarked at port Q. Embarked S for passengers who embarked at port S. In this case, we choose to keep all 3 columns instead of dropping 1, as it helps maintain the full distribution of the data. Since sex has only 2 values, it is easier to understand if we remove one, But for Embarked, we will keep all three to follow the data better. Let's go up and see an example. If we look at the first row, Mr. Brown here, he is a male, embarked at S. What does our definition say? We should have a column sex male as female is removed, and 3 columns S, Q, and C. Since he embarked at S, we should have true for embarked S and false of the other 2. That is correct. Our code worked. Go figure. In the Titanic dataset, we start by defining a list of age categories in an increasing order. Small child, teenager, young adult, middle-aged, senior. We have the age categories in order, from young to old, and we make sure that our data reflects this. Next, we apply ordinal encoding. Looking at the output, we can see that the age group column has been successfully transformed into numerical values. Let's check 1 or 2 examples. Age 22, age group young adult, has now value 3. Next, age 38, age group middle-aged, has now value 4. By using ordinal encoding in this way, we keep the natural ranking of age categories. Great! Now that we have successfully encoded the age group column, our dataset is becoming more structured and ready for further analysis. Let's continue. We want to build our machine learning model, and we need to decide which features from our dataset to use. Let's go through the steps of how to select the right features. First, we look at the data. We can use the head command to check the first 5 rows and see what kind of values we have. One of the first things we notice is that some columns are not relevant. For example, the name of the person, the ticket number, or the cabin. These features do not contribute to predicting survival, so we can remove them right from the start. Why would the name of a person influence survival rate? Is being a Jane better than being an Anne? Nope, not relevant. Hence, we can directly remove the columns that we think that do not have any relevancy. Next, we analyze how the remaining features are related. We use a correlation matrix where each row and column represent a feature from the dataset, showing how strongly they are correlated. For example, we see a negative correlation between survived and passenger class, with a value of around -0.33. That is because survived is 1 and not survived 0, and passengers in first class had a higher chance of survival, while those in lower classes had a lower chance. Let's visualize this correlation to understand it better. We can look at survived compared to other columns, either following the first row, or maybe it is simpler to use the first column since we have the labels here on the left. We see a strong relationship between survival and passenger class. Age not so much, fair. Young, age group, high correlation for sex male as expected since women were prioritized at rescue. Embarked C, embarked S. We previously mentioned that younger people had a higher survival rate, but when we check the correlation, it's not very strong. Why is that? One important question when developing machine learning projects is to ask questions. That's because not all young people survived, and not all older people died. We use a box plot to better understand how age is distributed among survivors and non-survivors. From the box plot, we see that the middle range of the data looks quite similar for both survived and non-survived passengers. This explains why the correlation is weak. Instead of looking at exact ages, we grouped passengers into age categories, such as children, teenagers, young adults, middle-aged, and seniors. Now, if we check survival rates within these groups using a count plot, we immediately see a clear difference. We see that survival rates were highest for small children and lowest for seniors. To quantify this, we calculate the percentage of survivors in each age group. We see that around 70% of small children survived, while only 12% of seniors survived. We display this as a bar chart, making it clear that younger age groups had a much better chance of survival. As you can see, looking at the same data, age in our case, from a different angle show better insights. That is exactly what you have to do. I used to have a print in my office that said, "If you torture data enough, it will confess." This phrase was coined by economist Ronald Coase, and I like it because it really represents the work of a data scientist. You have to turn data on all angles so that it confesses. We need to choose a model based on the type of prediction we want to make. We have two major categories of models. Regression models, if we want to predict a continuous value, like house prices. Classification models, if we want to predict a category, like spam or not spam. There are a wide range of pre-existing models, and you can test several and see which one works best for you, of course, out of those that make sense for your problem. Let's explore these two categories and see some examples. If you want to predict a certain value, we use regression models. Some common regression models include linear regression, the simplest model, drawing a straight line through the data to predict values. This is the most known and most used as a first attempt for a regression problem. You can remember its name if you remember that it tries to draw a straight line through the data. Polynomial regression, a more advanced version that captures curves in the data. Moving on to classification models. Classification models are used when the target variable is a category. There are two types of classification problems. Binary classification. The target has only two categories, yes or no, true or false. Multiclass classification. The target has more than two categories, dog, cat, lion. Classification models use probability to decide the probability of belonging to one class. Let's start with the basic one, logistic regression. This is a simple classification algorithm used when the target variable has two categories. For example, survived, not survived. Even though it has regression in its name, it's actually used for classification, not predicting continuous values. Next, decision trees. A decision tree is a flowchart-like model that splits data into yes, no decisions at each step until it reaches a final classification or prediction. It is like a tree with a root and go on onto each branch that can split into several possible scenarios. It mimics human decision-making by asking a series of questions and following the path based on the answers. It is very useful when we need to be able to explain the reasoning of a machine learning model. It is like it creates a lot of if-else rules, making them easy to understand. For example, in our Titanic data, it can start with the condition. Was it male or female? If female, go check these conditions. If male, check other conditions. We also have random forest. This actually combines multiple decision trees and makes use of their results when deciding the result. For example, if 4 out of 5 trees decide one value, the random forest may pick it as being the correct one with a higher probability. These are some examples. There are many more other machine learning models included into the most common machine learning libraries, but they form a good base to get started and try them. You don't try them all blindly. You decide based on the type of your problem what to try. You made it to the interesting part. That is great. In this session, we'll go step by step through the process of building a machine learning model from scratch. Let's get started with a small memory refreshing. To build a supervised learning model, we need labeled data. We have the features, namely the relevant information that we will use for our model, and the label, or the result of each example row. We call this the target variable, or simply put what we want to predict. In our Titanic example, the target is the survived column. We want to predict if a person survived or not, looking at all the other data. While preparing a machine learning model, we go through several steps. We start with the input labeled data. Next, we decide which are the features and which is the target. We usually use capital X for the features and lowercase y for the target. Once again, the features or X are the inputs, or the variables we use to make predictions. The target or Y is the output, or the value we are trying to predict. Good. Now we move on to splitting the data into train and test. Once we have our data, we don't train the model on all of it. Instead, we split the data into two parts: training set and test set. Training set is the data used to train the model. It teaches the model the patterns and relationships between the features and the target. This one, once again, has two parts: X-train for the training features and Y-train for the training target. Test set. This helps evaluate how well the model performs. We keep it on purpose unseen for the model so that we can test its performance. It ensures the model has learned to generalize and not just memorize patterns for particular rows. Once again, it has two parts: X-test for test features and Y-test for test target. A common practice is to allocate 80% of the data for training and 20% for testing, or 70% of the data for train and 30% for test. Next, we move on to training a machine learning model. We will go step by step through training supervised learning models using the Titanic dataset. Our goal is to predict whether a passenger survived or not based on different features. Let's follow what we have discussed previously and see how to put it in practice. We said that the first step is to select features and target. Let's take one more look at the data. If we go in our notebook one step up from the previous lesson, we have prepared a list of most important features. Based on these, we can select sex male, passenger class, fare, embarked C, embarked S, and age group. These are the features that we want to keep. Scaled or not scaled, it depends on the model to be used. We start with the original values, not scaled, for the first model, which is able to handle original data. For the target variable, we will use the survived column. We create a new data frame called Y, where we will have only this column. Step 1 completed. Moving on to step 2, which is splitting the data into train and test. In the end, we have X train, X test, Y train, and Y test. We move on to step 3, training the model. We want to classify if the person survived or not, which means that we need a classification model. We only have 2 possible outcomes, so 2 classes, hence we can use a binary classification or a multi-class classification model. Shall we see some examples? Option 1, decision trees. We can use the scikit-learn library. This has a lot of built-in machine learning logic. We import the decision tree classifier and the accuracy score function that we will use at the accuracy of the results. First, the model was initiated using the decision tree classifier function. Then, the fit function was applied to the training data, allowing the model to learn patterns. This is actually the training part. After training, the predict function was used on the test data to generate predictions. Finally, the accuracy was calculated by comparing predictions with the actual survival values using the accuracy score function. An accuracy of 0.82 means that in 82% of the cases, the model predicted correctly that the person survived or not. That's it. It is really that simple to create machine learning models. It's a waltz of 1-2 tree. Select features, split into train and test, train, 1, 2, 3, 1, 2, 3. The scikit-learn module makes your life easier when creating these models. Unsupervised learning. We have discovered until now how to create some supervised learning models. Let's move on to unsupervised learning. Unsupervised learning is a type of machine learning where a model learns patterns and structures from data without labeled examples. Think of it like this. Imagine a field full of flowers, and you have no idea what they are. You start grouping them based on their appearance, their color, or size. That's what unsupervised learning does. It finds patterns without being told what to look for. Key differences from supervised learning. No labeled output. In supervised learning, we have labeled examples, meaning we know the correct answers in advance. For example, we have apples and bananas, and we have images with apples with the corresponding apple label. We have images with bananas with the corresponding banana labels. But in unsupervised learning, there are no predefined labels. The algorithm figures out structure and patterns from raw data. In unsupervised learning, we don't have labeled data. We focus on inference rather than prediction. Instead of predicting specific outcomes, unsupervised learning tries to understand the hidden structure of the data. It groups similar things together or reduces complex information into a simpler form. Key techniques in unsupervised learning. There are 2 main techniques used in unsupervised learning. Clustering. This groups similar data points together. Some common clustering methods include k-means and hierarchical clustering. We'll talk more about this with a concrete example with k-means in a moment. Dimensionality reduction. This technique reduces the number of features while still keeping important information. Some popular methods are PCA, Principal Component Analysis, and TSNE, T, Distributed Stochastic Neighbor Embedding. Imagine you have a massive spreadsheet with hundreds of columns. Dimensionality reduction helps shrink it down to a smaller number of important features while keeping the essential patterns intact. K-means clustering. Let's take a closer look at one of the most popular clustering methods, namely K-means clustering. The algorithm looks for natural clusters in the data and organizes similar points together. Before K-means, the data is scattered randomly. After K-means, we see clear groups, each representing a cluster of similar data points. Steps of K-means clustering. Choose the number of clusters, K. We decide how many groups we want in advance. Initialize centroids randomly. Centroids are like the central points of each group. Initially, they are placed randomly in the dataset. Assign each data point to the nearest centroid. Every data point is assigned to the closest centroid, forming groups. Update centroids. The centroids are updated by calculating the mean of all the assigned points. This means they move to a new position that better represents their group. Repeat steps 2 to 4 until convergence. The algorithm keeps reassigning points and adjusting centroids until the groups stop changing. After running K-means, we get well-defined clusters where similar points are grouped together. This method is commonly used in customer segmentation, market analysis, and even in image compression. This technique involves clustering the pixels in an image into a smaller number of groups and then representing each group by its mean color. Should we check out a concrete example? Want to practice? Check out this mall customer dataset. You can find it on Kaggle and some other sources as well, since it is a good dataset to get started to understand clustering. We have a dataset with customers with the customer ID, genre, age, and annual income and a spending score. We want to group these people into several groups so that the marketing team can approach them differently based on their group definition. We can go together over a notebook and see step by step what we do when we want to do some clustering. Mall customers. Unsupervised learning. In this notebook, we will explore unsupervised learning techniques to analyze the mall customer data. Our goal is to find patterns in the data and group similar customers together using clustering methods. This will help businesses understand different types of shoppers, improve their services, and it will let the marketing team know how to approach them. We begin by mounting Google Drive, which allows us to access files stored online in Google Drive. This step is useful when working in Google Colab, as I am doing now. I like it a little more than a regular Jupyter notebook, since it has slightly easier options for formatting the text cells. Step 1. Load the data. First, we need to load our dataset. We load the mall customers CSV file, and we display the first 5 rows to get a first glimpse of the data. Next, we use the describe function to understand the scale and values of the data. We can see that we have 200 rows, and we take a look at the mean, minimum, and max values of the columns that we have. We start to understand it better before moving on to data processing. Step 2. Pre-process the data. First, we remove the customer ID. For sure, an ID will not influence the results, hence we simply drop it. Moving on, we have a categorical column, namely genre. You remember from previous lessons that we can use one-hot encoding to encode this type of columns, and this is exactly what we do here. We use the getDummies method and we drop the first resulting column. Of course, if we have for a row male, for sure we will know how to infer the genre female and genre male columns using just one. Next, we standardize the data. K-means is very sensible to the scale of the data, so we scale our data frame. After all these transformations, we have the DF-scaled NumPy array started from our original data frame. This one has no customer ID, an encoded genre, and scaled values. Step 3. Find the optimal number of clusters. Before applying K-means clustering, we need to determine the best number of clusters, or K. There are 2 main methods to do this. 1. Elbow method. The elbow method helps us determine the optimal number of clusters by computing within cluster sum of squares, WCSS, against different values of K. This one measures the sum of squared distances between each point and the centroid of its assigned cluster. As K increases, the within cluster sum of squares decreases, but after a certain point, the improvement is minimal. The elbow point on the graph indicates the optimal K value. It is just like the elbow, which is the bending point of the hand. We generate a plot to visualize it better by running k-means for different values of k, ranging from 2 to 14, and observing where the curve bends. In this for loop, we go with I from 2 to 14. 15 is exclusive here. We initiate the k-means model with n clusters equals I. We set a random state for predictability. NN init is a parameter that controls how many times the k-means algorithm runs with different initial centroids before selecting the best clustering result. This n init equals 10 means that it runs k-means 10 times with different random centroid initializations, then picks the best result. We fit the model on our scaled data and we compute the inertia, or the within cluster sum of squares. We plot the resulted values. Looking at the results, it is not very conclusive. That's okay. We have another method as well. Silhouette score. The silhouette score is another method to evaluate clustering performance by measuring how well separated the clusters are. It measures how similar each point is to its own cluster compared to the nearest neighboring cluster. The score ranges from -1 to 1. +1 means well-clustered data, where points are close to their own cluster and far from others. 0 means overlapping clusters. -1 indicates poor clustering, where points are assigned to the wrong clusters. We calculate the silhouette score for different k values and plot the results. The highest silhouette score suggests the best k for the number of clusters. We do the same steps as above. We iterate with I from 2 to 14. In this step, we also do the predictions with fit predict. This method trains the model and does the predictions. The result is the labels array, which holds values from 2 to 14, with the predicted cluster index for each data point from our 200 rows. We print it for k equals 2 so that you can see it. We print also the silhouette score for each k after we compute it using the silhouette score method that takes as arguments the data and labels. We store all these scores in a list so that we can use it below for plotting. We use the plot method. On the x-axis, we have the values from the range, and on y, we have the silhouette scores. We have a circle for marker to mark the intersection of x and y for each value. We use dotted lines for the line style and green as selected color. We plot the results and we also can look at the values. Starting with 10, we can see some values higher than 0.4, but not so much of a difference between them. Well, some separation, but not the best separation here. If only we could see it. Actually, we can. We can use PCA, which is, again, another unsupervised learning technique. This one is used for dimensionality reduction, and we can reduce the space to 2D. Instead of our 4 features, age, genre, annual income, and spending score, we compute 2 new values so that we look at the results. I will not insist now at this PCA, since we will explore it more in the next lesson. For now, it is sufficient to know that it generates a new data set with n components as selected. It is useful to visualize the data in 2D. Hence, we use 2 components here, and we transform the data and the centroids so that we can visualize them better. We initiate here the k-means model with 14 clusters, since we had the highest score for 14, and we compute the predicted labels. Next, we visualize the clusters, with the centroids marked by this white box with the cluster number on it. As you can see, we have some separation, but also some overlap. Pretty cool, no? I find it interesting that you can look at the data in 2D. Yep, it's cool. My daughter says that it is not cool to say cool, but I have decided to ignore this and still use this word. Back to our problem. So, what do we do when the results are not the best? Answer: we keep going, keep trying. Could we improve the silhouette score? Moving on to the next step, feature selection. Probably our first try did not pick the best features. Let's try one more time by selecting only annual income and spending score. We do the same steps, we select the data, scale it, and move on to elbow method and silhouette score. This time is different. We can see the bending point or the elbow for k equals 5. If we look at the silhouette score below, we can see that the highest value is 0.55 for k equals 5. Just have a look at this plot. It is clear the highest point. That is great. We can now move on to building our final model. Step 5. Apply k-means clustering. Now we apply k-means clustering with the selected number of clusters, in our case 5. We add a new column named cluster in our DF selected data frame, which holds the result of the predictions from k-means. And if we look at the resulting data frame, we can see this new cluster column here. Step 6. Visualize the clusters. After clustering the customers, we visualize the results using the same scatter plot as before. Each cluster is assigned a different color, making it easy to see how customers are grouped based on spending patterns and income levels. We have now just 2 columns, and we could have easily visualized it. But just to keep it similar, we use the same visualize data in 2 days with PCA method. As you can see, our clusters are much better separated. This separation helps businesses target specific customer groups differently based on their characteristics. How to find them? Let's have a look at the resulting clusters and try to explain them. We group the resulted data frame by cluster, and we compute the mean values for each feature. Now, we try to make sense of this data. Cluster 0, middle income, moderate spending. Customers with average income, around $55,000, and moderate spending habits, around 49.5. Likely to include middle-class customers who balance spending and savings. Cluster 1, with high income, high spenders. Customers with high income around 86,000 and high spending score around 82. Could represent wealthy shoppers who spend a lot like luxury buyers, VIP customers. Cluster 2, low income, high spenders. Customers with low income around 25,000 but high spending score around 79. Could be young shoppers who spend impulsively or use credit. Could also include students or trend followers. Cluster 3, high income, low spenders. Customers with high income around 88,000 but low spending around 17. Likely frugal customers who prefer saving to spending, may include minimalists or cautious buyers. Cluster 4, low income, low spenders. Customers with low income around 26,000 and low spending score around 20. Likely budget-conscious or low purchasing power customers. Could include retirees, students, or financially conservative individuals. As you can see, by applying unsupervised learning, we were able to segment customers into meaningful groups. This analysis can help businesses understand their customers, personalize marketing strategies, and improve customer experience. And that's it. Now you understand how clustering techniques like k-means can uncover hidden patterns in data. Feel free to experiment with different datasets and clustering methods to gain more insights. K-means clustering. Let's take a closer look at one of the most popular clustering methods, namely k-means clustering. The algorithm looks for natural clusters in the data and organizes similar points together. Before k-means, the data is scattered randomly. After k-means, we see clear groups, each representing a cluster of similar data points. Steps of k-means clustering. Choose the number of clusters, k. We decide how many groups we want in advance. Initialize centroids randomly. Centroids are like the central points of each group. Initially, they are placed randomly in the dataset. Assign each point to the nearest centroid. Every data point is assigned to the closest centroid, forming groups. Update centroids. The centroids are updated by calculating the mean of all the assigned points. This means they move to a new position that better represents their group. Repeat steps 2 to 4 until convergence. The algorithm keeps reassigning points and adjusting centroids until the groups stop changing. After running k-means, we get well-defined clusters where similar points are grouped together. This method is commonly used in customer segmentation, market analysis, and even in image compression. This technique involves clustering the pixels in an image into a smaller number of groups and then representing each group by its mean color. Should we check out a concrete example? Want to practice? Check out this mall customer dataset. You can find it on Kaggle and some other sources as well, since it is a good dataset to get started to understand clustering. We have a dataset with customers with the customer ID, genre, age, and annual income and a spending score. We can go together over a notebook. Our goal is to find patterns in the data and group similar customers together using clustering methods. This will help businesses understand different types of shoppers, improve their services, and it will let the marketing team know how to approach them. I will not go over the code. That is not the purpose here. There are some algorithms to evaluate the results using different K values. You go through the same steps: data preparation, feature selection, and you evaluate the results. I did just that, and it got me here. Let's have a look at the resulting clusters and try to explain them. We group the resulted data frame by cluster, and we compute the mean values for each feature. Now, we try to make sense of this data. Cluster 0, middle income, moderate spending. Customers with average income, around $55,000, and moderate spending habits, around 49.5. Likely to include middle-class customers who balance spending and savings. Cluster 1, with high income, high spenders. Customers with high income around 86,000 and high spending score around 82. Could represent wealthy shoppers who spend a lot like luxury buyers, VIP customers. Cluster 2, low income, high spenders. Customers with low income around 25,000 but high spending score around 79. Could be young shoppers who spend impulsively or use credit. Could also include students or trend followers. Cluster 3, high income, low spenders. Customers with high income around 88,000 but low spending around 17. Likely frugal customers who prefer saving to spending, may include minimalists or cautious buyers. Cluster 4, low income, low spenders. Customers with low income around 26,000 and low spending score around 20. Likely budget-conscious or low purchasing power customers. Could include retirees, students, or financially conservative individuals. As you can see, by applying unsupervised learning, we were able to segment customers into meaningful groups. This analysis can help businesses understand their customers, personalize marketing strategies, and improve customer experience. And that's it. Now you understand how clustering techniques like K-means can uncover hidden patterns in data. Introduction to deep learning. Deep learning is a powerful technology that helps computers learn from data, just like humans do. But instead of using common sense, it relies on math and a lot of data. Before we dive into deep learning, let's take a step back and understand where it fits in the world of artificial intelligence. A reminder from previous lesson. Let's see, where does deep learning fit in? What is artificial intelligence? Artificial intelligence, or AI, is when machines simulate human intelligence. What about machine learning? Machine learning, or ML, is a subtype of AI. Instead of programming a computer with step-by-step instructions, machine learning lets computers learn from data, making use of algorithms and statistical models. And finally, deep learning. Deep learning is a special kind of machine learning. It uses neural networks with multiple layers to model and understand patterns in complex data. These are inspired by the human brain. Think of it like a detective solving a case. Each layer of the network picks up clues and passes them along until the final answer is found. To understand artificial neural networks, let's first take a look at how real biological neurons function in the human brain. In our brains, neurons are tiny but powerful messengers. They communicate by passing electrical and chemical signals from one neuron to another. Imagine a group of friends passing notes in class. One person writes a message, hands it to the next, and the message keeps moving until it reaches the right person. This is similar to how neurons pass signals through the brain. Each neuron has three main parts. First, there are dendrites. These are like little antennas that receive signals from other neurons. Then there is the cell body, which holds the genetic information. Finally, we have the axon. The signal travels through the axon, which is like a long wire that sends the message to the next neuron. When enough signals combine, the neuron activates and passes the information forward. Artificial neurons work in a similar way, but instead of biological signals, They use numbers and mathematical operations to process information. Imagine an artificial neuron as a simple decision maker. It takes in numbers, processes them using a special function, and then decides whether to pass the result to the next neuron or not. A neural network is made up of many of these artificial neurons, connected in layers. Let's talk a bit about these layers. First, we have the input layer, where raw data, like an image or text, is fed into the system. This layer has as many neurons as the size of the input data. For example, for an image, it will be the number of pixels in that image. Then the data moves through hidden layers, where the real magic happens. Each layer extracts different patterns, step by step, just like recognizing the shape, color, and texture of an object in an image. Finally, we reach the output layer, which gives the final prediction. If the network is trying to recognize animals, it might say, "This is a cat," or "This is a dog." Here we are talking about probabilities. For example, if we want to classify an image of an animal, and we have 4 options, the output layers will have 4 neurons. Each such neuron will represent one class, and it will hold the probability that the model computed for that class. The class with the highest probability can be selected as the winning class, and the answer to the question, "What animal is in this picture?" Now on these layers. The more layers it has, the deeper the network and the better it gets at understanding complex data. Up to a certain point, of course. Now that we understand how artificial neurons work, let's compare deep learning with traditional machine learning and see why deep learning is so powerful. How does deep learning compare to traditional machine learning? Traditional machine learning needs human help to find the important features in data. The process for building a machine learning model is as follows. We have the input, and a person selects key characteristics or features. Next, we would have a machine learning model, for example, for classification, and in the end, we get to an output. Deep learning, on the other hand, does everything automatically. The model learns how to find useful patterns and classify the data at the same time. It works especially well for images, speech, and complex tasks. So the first strength of deep learning that we encountered is the ability to skip the feature extraction stage. Instead of requiring manually engineered features, deep learning models automatically learn representations from data. Pretty awesome, no? More? Well, of course. Next on deep learning strengths is its scalability. Andrew Ng, a famous AI researcher, once compared deep learning to a rocket ship. He said, "I think AI is akin to building a rocket ship. You need a huge engine and a lot of fuel. If you have a large engine and a tiny amount of fuel, you won't make it to orbit. If you have a tiny engine and a ton of fuel, you can't even lift off. To build a rocket, you need a huge engine and a lot of fuel." The analogy to deep learning is that the rocket engine is the deep learning models, and the fuel is the huge amounts of data we can feed to these algorithms. Deep learning can handle large volumes of data and is highly effective when trained on big data sets, winning points at the scalability criteria when compared to traditional machine learning. There are cases where traditional machine learning will yield better results. However, for large or complex data sets, deep learning would be a better fit. To build a deep learning model, the process is similar to the traditional machine learning. You start with the training data, and you can use certain libraries that help this process. Machine learning is a game of knowing what to use in which context, and a lot of experimentation. To actually get to build such a model, you have helper libraries that really facilitate the implementation. One such library that we can use for building deep learning models is TensorFlow, often together with Keras. TensorFlow is a low-level library. Keras is a higher-level library that is built on top of TensorFlow to have an easier setup for building neural networks. So what is TensorFlow? TensorFlow is an open-source machine learning framework developed by Google. It's like a giant toolbox that helps developers build, train, and use AI models for different applications. Now, let's talk about why TensorFlow is so popular. First, it's scalable. You can run it on different hardware, from small CPUs to powerful GPUs and even specialized processors called TPUs that Google developed to accelerate machine learning workloads. It stands for Tensor Processing Units. Now, our TensorFlow, it's scalable, but it's also flexible. It's not just for deep learning. You can use it for traditional machine learning and even reinforcement learning, which is used in things like gaming AI. TensorFlow is also production-ready. Backed by Google, it's designed to work well in real-world applications like web platforms, mobile apps, or cloud services. Besides this important commercial support, TensorFlow also has a strong community. Because TensorFlow is widely used, there are tons of tutorials, examples, and resources available to help you learn. Another big benefit is ease of use. TensorFlow makes it easier to build AI models, especially for deep learning, where you need to process a lot of data. Pretty great, this TensorFlow. If deep learning is so great, where is it used? Deep learning is everywhere. Chances are you've already interacted with it today. Here are some real-world examples. For example, for computer vision is used in face recognition, medical imaging, and object detection. Natural language processing helps computers understand and generate human language, like in chatbots and translation apps. Self-driving cars use deep learning to detect lanes, recognize traffic signs, and avoid obstacles. Speech recognition powers voice assistants like Siri, Alexa, and Google Assistant. And finally, deep learning is used in data analysis, helping industries like finance and healthcare find patterns and predict outcomes. Deep learning is a game changer in AI. It can process large amounts of data, recognize patterns, and make decisions just like humans, but at a much larger scale. Whether it's recognizing your voice, improving medical diagnoses, or powering self-driving cars, deep learning is shaping the future of technology. This was just a basic introduction, but I hope it gives you an idea of how powerful deep learning can be. Stay curious and let's move on to discover it in more details. Introduction to object detection. Have you ever wondered how self-driving cars know when to stop? Or how your phone unlocks just by looking at your face? The answer is object detection. So what is object detection? It's a technique that uses neural networks to find or recognize objects in pictures. This type of artificial intelligence helps computers identify objects in images. It doesn't just say what's in the picture, it also shows where each object is. Let's compare object detection with other tasks that computers can do with images. When we talk about recognizing images, there are three main tasks. Image classification classifies an image, tells what is in a picture, like saying, "This is a cat." Object detection finds one or more objects and their locations, like saying, "Here's a cat and here's a dog." Image segmentation tells exactly which pixels belong to each object. Similar to object detection, it identifies an object and its location. But instead of specifying the area where an object is, it finds the exact shape of objects, like saying, "These pixels belong to the cat, and these belong to the dog." Let's see a visual example. Image classification. This is when the computer looks at an image and tells us what's in it, like looking at a picture and saying, "That's a dog." Object detection. Here we go a step further. The computer tells us what is in the image. It can be one or more objects, and it will tell us exactly where they are in the picture as well. For example, it might say, "There's a dog in this box and a cat in that box." Image segmentation. This is the most detailed one. Instead of just drawing boxes, the computer figures out which exact pixels belong to each object. It knows, pixel by pixel, what is a dog and what is a cat. Well, we see things with our eyes, but computers? They see pixels, tiny little squares filled with numbers. Each pixel represents a color or brightness. If the image is colored, the pixels will have 3 values in RGB: red, green, blue. Let's take our dog and cat over here. This point, where the arrow points for the dog, has this brownish color. I saw brownish, but the computer actually sees its value in red, green, blue. Each color can be represented by a mix of these 3 colors. So, for the computer, this pixel will be 208, 147, 99. If the picture is black and white, each pixel will have only one number, with the brightness or the gray intensity. By analyzing these numbers, the computer can understand what's in the image. For object detection, computers use bounding boxes. These are just rectangles drawn around objects to show where they are. If we give an image to an object detection model, it draws these boxes around each object, just like saying, here's a cat, and here's a dog. Object detection is super useful. Here are some ways we use it. Self-driving cars. Detects other cars, traffic lights, and people to drive safely. Security cameras. Identifies faces and spots unusual activities. Medical imaging. Finds diseases in X-rays or scans. Fire detection. Spots wildfires before they spread. Augmented reality and social media filters. Places virtual objects in the real world, like those fun face filters. And that's a quick look at object detection. It helps computers understand and interact with the world just like we do. Cool, right? To my daughter, I know is not cool to say cool, but yet again, here we are. Let's talk about data labeling, one of the most important steps in teaching an AI model. Imagine you're teaching a robot to recognize things in the world, like cats, dogs, cars, or even happy and sad faces. To do this, the robot needs examples. And not just any examples, it needs examples that are clearly explained. That's where data labeling comes in. Let's say you have a picture of a dog. You add a label that says, dog. Boom. That's data labeling. Now, imagine you have 1,000 pictures. Some are dogs, some are cats, and some are birds. Each one needs the right label, so the robot knows what it's looking at. This labeled data helps the robot learn the difference between things. Labeling doesn't just work with images. It can be used for text, audio, and even video. For example, in text, you might label the emotion in a sentence, like happy or angry. In audio, you might label a sound as laughter or applause. All of this labeled data helps machines learn better and faster. So yeah, data labeling might sound boring at first, but it's like giving your AI a superpower, because without labels, it's just guessing. All right, now that you know what data labeling is, you're ready to go teach some robots. Let's move on and see how it works in action for object detection. If you're building an object detection model, you need a bunch of images that are clearly labeled. The better your labeling, the better your AI model becomes. It's simple. Good labeling equals a good model. Bad labeling? Well, that's like teaching with the wrong answers. For object detection, data labeling means creating rectangles or bounding boxes around the area of an object. Each example has a class name, which represents that class, and a bounding box around the found object. Here we have such an example. We will take a look at an example for a car detection using a Kaggle dataset. You can see with purple in the lower part of the image that we have the class name car. Around each car from the picture, we have a bounding box, or a rectangle. Now, there are different techniques to label data. First, we have the obvious manual annotation. This means a human draws a box around each object in an image. It takes time, but it's super accurate. Next is semi-automatic labeling. Here the computer helps out. It guesses the labels and a person checks if it's right. A nice teamwork moment. Then we've got synthetic data generation. This is when we create fake but realistic images using computers, and they come already labeled. Super useful when real data is hard to find. Some of the popular tools you can use are Label Studio, CVAT, and RoboFlow, but there are more. Pick the one that suits you best, either that you want to have it full offline or on-prem, or one that can help you ease the labeling with a semi-automatic labeling. The tool is less important for the result. I am using for our example Label Studio that has an on-prem option and also the possibility to make use of AI model predictions for labeling. It is a good candidate to get started. I also like RoboFlow. This one is more advanced, but there is a price to be paid for private data and models. Back to Label Studio. To install it, you can do it easily using pip. Simply issue pip install Label Studio. U simply means to upgrade the package if you have it installed. No need for the first run. After installation, you can launch it with Label Studio. And that's it. This will open Label Studio and you can label some data. Let's go over an example together. To create a new project, simply push the Create button and pick a name for your project. I am creating a new project and I will call it Test Project. Now, to import some data, go to Import and you can select pictures to label or even a whole batch as an import JSON file. To import pictures, select the ones that you want and click Import. If you click on the imported image raw, it will take you to set up the labeling interface. This is just one time only. If we go to Visual Browse Templates, we can select the one for object detection. It starts with a sample data with planes and cars. We remove them and we can add our own label, in our case, car. If we go back to the picture, we can see the newly created label in the lower left part. We select it and we can use it to draw rectangles representing that class. For example, we have a car here. And another car here. When you're done with one car, you just move on to the next. And you do this over and over again until all your objects and all images are labeled. When done, click on Submit. We can also import a dataset if we have one already labeled. I have found one good learning example on Kaggle. It's a car detection dataset containing 499 images with bounding box annotations for cars. I can download it and import it into Label Studio. Once done, you should see the data that was labeled. You can add more images or update the labels if you don't like something about them. Once finished, you can export the final data and move on to building the object detection model. When working with YOLO text data, the data is as follows. You have a folder, usually called Images, that will hold the pictures. Another folder, called Labels, stores the corresponding labels. You have one such label text file for each corresponding image that will hold the labeled objects for that image. A file called classes.txt holds the class names in order, one per line. First line corresponds to class index 0, second line to class index 1, and so on. More on these labels. During labeling, we define each object's location visually with a bounding box. Now, take a look at this image. We have two people, and each person is surrounded by an orange rectangular box. Another green box is around the tie. Each box is described using 4 values: the x and y coordinates of the center of the object, the width of the box, and the height of the box. Everything is normalized, which means the values are between 0 and 1. This makes sure the data works for images of any size. In the bottom section, we see a text file. This is the corresponding file with labels for this image. Each row in this file represents a labeled object in the image. Let's break it down. The first number is the class number. This tells us what kind of object it is. For example, if 0 represents a person, then any row starting with 0 means the object is a person. Next, we have the x and y coordinates of the object's center. In the first row, x is 0.48 and y is 0.63, meaning the center of this object is around the middle of the image. Then we have the width and height of the bounding box. For example, the first object has a width of 0.69 and a height of 0.71. This bounding box covers a big part of the image. Each row follows the same pattern: class number, x center, y center, width, and height. We will not work directly with the text file, but rather in a visual manner in a labeling tool like Label Studio. But it's important to understand the data that will be passed on. Hey there! Let's dive into the world of object detection and take it for a spin. In this lesson, we're going to learn how to build and how to use object detection models. Sounds like magic? Well, it's more like math, but cool math. To keep it really simple, let me introduce to you YOLO from Ultralytics. We mentioned it previously. YOLO, standing for You Only Look Once, is a single stage model. This means that it finds objects in one step of going over the image. It is fast and can be used in real-time applications. Ultralytics also offers some helper platform, but we will focus on the code. You can see the screenshot from Ultralytics' website with their models and available tasks and actions. First, we can see that we have different models. That is because YOLO has some pre-built models that we can use. Some are larger, with more parameters and better results, but higher inference times. The models go from N nano, then we have S small. We also have M medium, L large, and X extra large. The more you go up, you will have better results, but the smaller models will run faster. Let's look at the kinds of tasks we can do with images using YOLO. The first one is object detection. This means the computer finds objects in a picture and draws a box around them, like finding a dog, a person, or a car. Then we have image segmentation. Here, the model finds the exact shape of the object, not just a box. It's like coloring just the cat and not the background. Next is pose detection, or key points. This is like detecting where someone's head, elbows, knees, and feet are. Oriented detection is still object detection, but the boxes can be rotated. This helps when the object is tilted or rotated. And finally, classification. That just means saying what is in the picture, like, this is a banana, or this is a stop sign. We mentioned object detection, segmentation, and classifications as image recognition tasks. These, plus some more, are easily integrated into YOLO. Now let's talk about actions, the different things we can do with our model. Inference is when the model is used in real life to make predictions. Validation checks how good the model is doing. Training is where the model learns from images. Export is when we save the model to use it somewhere else, like in an app or a website. We can export models into different formats. I mentioned pre-trained models. A pre-trained model means it's already been trained by someone else using a big data set, so we can just use it without starting from zero. That's great when we want results quickly. YOLO can detect things like people, animals, cars, laptops, bottles, cell phones, handbags, and so much more all at once in one image. We don't even have to have any data set for it. So instead of starting from scratch, we simply borrow this work and use the model to detect objects right away. Now, with just one line, we have a ready-to-use model that knows how to look at an image and find the objects inside it. No training, no extra steps, just plug and play. And if we want to make predictions with this model, we simply call it on an input. Result.show displays the image with the predictions. And now, really, that's it. Even with extra details and extra prints, that is all. You can see the predictions on this image. The model has detected persons, cell phone, a bottle, a backpack, some handbags, a laptop, and a suitcase. Each prediction has a bounding box, but also a confidence level. In some cases, the model is more confident, but in some, not so much. You can decide, based on your particular use case, if you really need high confidence levels before validating a prediction, or you can accept less confidence, but more objects found. For example, the model thinks that there is a suitcase with a 0.49 confidence. If you only accept objects if the confidence is higher than 0.5, then this object will be skipped. Once again, it depends on your use case. And speaking of use cases, let's see what classes this model knows and you could use. There are many classes included in this COCO dataset that the pre-trained models knows of. COCO stands for Common Objects in Context. It is a large-scale dataset with a wide variety of object categories. This dataset has thousands of pictures with objects like people, animals, and everyday items. The cool thing is, the objects are shown in real situations, like a person walking a dog on a street. It is an essential dataset for researchers and developers working on object detection tasks and commonly used for benchmarking computer vision models. Let's take a look at all the different classes the model knows. It has 80 classes, including person, bicycle, cup, laptop, or toothbrush. I have listed all of them here, but what happens when you want something else? Well, who said that we cannot build our own magic? Now let's say you want to create a model for something more specific, like detecting if someone is wearing a face mask. There's a great dataset on Kaggle with tons of images of people wearing masks and not wearing masks. This helps the model learn the difference. I've told you, Kaggle has many interesting datasets. So this dataset has 800 plus images with people wearing masks, not wearing masks, or wearing masks improperly. Let's move on to model building, our custom objects. Let's see what happens when we use this model on the same image, only that this time we taught it detect people wearing masks, not wearing a mask, or wearing it incorrectly. And look at that. We have our resulted image with the bounding boxes and confidence levels. Pretty great, no? It is really that easy. Once you have the dataset, you define the configuration file, and you train the model using a pre-trained model as starting base. I do like it a lot when it is this easy. I've told you, machine learning is not that difficult if you have a little guidance to point you in the right direction. Welcome. In this lesson, we'll explore natural language processing, what it is, why it's important, and how it powers many of the tools you already use every day. It is the base for the extra-famous ChatGPT. Now, you will understand the theory behind it. So let's get started. What is NLP? Well, NLP stands for Natural Language Processing. It is a part of AI that helps computers understand and work with human language. NLP allows computers to work with language in a human-like way, understanding what we say, processing it, and responding appropriately. Basically, it's like teaching computers to listen, read, and even talk back. All right, imagine you're listening to someone talk or reading a book. You understand what it's meaning, right? Of course you can understand it, given that it speaks your language. NLP helps machines do the same thing. It's all about helping computers understand texts, just like you do. But we must still be aware that this understanding differs from what us, humans, call understanding. It actually is an understanding of the numbers resulting from a text command. And not only texts, NLP also helps with speech recognition. That means machines can hear and understand what people say, kind of like when your phone hears you say, "Hey Siri," or "Okay Google." That's NLP in action. So, why do we even need NLP? In short, NLP makes human-computer interaction smoother. It makes this interaction more naturally and more inclusive. It's not just programmers now that can speak with machines. This interaction became more inclusive thanks to NLP. And why do we want to speak with machines? Simple, because it can help us automate many things, freeing up valuable time. As NLP techniques progressed, computers can capture now better nuances and context. Not perfect, true, but they can to some extent. Making use of natural language processing, people can now gain more insights from vast amount of data. Think about customer survey satisfaction reports or movie review. See what I mean? NLP has made it possible for us to interact with machines more naturally, whether through typing, speaking, or even just searching online. From spam filters to Siri, NLP is already part of your digital life, even if you didn't realize it. Let's look at some real-life examples. Chatbots, those little helpers on websites, use NLP to chat with you. Translation tools like Google Translate? Yep, NLP again. Search engines like Google? They use NLP to figure out what you're looking for. Voice assistants, like Alexa or Google Assistant, use NLP to understand your commands. Even your email uses NLP to filter out spam. And when companies want to know if people are happy or upset in reviews, that's called sentiment analysis. They use NLP too. So yeah, NLP is kind of everywhere. But it's not always easy. It has its challenges. Let's have a little fun here. When you say "I'm cool," what do you really mean? Are you talking about the temperature? Or are you saying you're awesome? See, humans get it. We understand the meaning from the context. But machines? They need help figuring that out. Sometimes it's ambiguity and context sensitivity. For example, bank is the financial institution or riverbank. You know from context. We have slang, dialects, and multilingual issues, while sarcasm and emotions are hard to detect without tone, only from text. Language is messy, full of ambiguity, double meanings, and emotional nuance. That's what makes NLP both challenging and fascinating. To be able to capture all this diversity, NLP techniques have progressed along the time. Each step made NLP smarter and more powerful. We started with rule-based systems. These used grammar rules and keywords that people had to write by hand. Then came machine learning models. These used statistics and lots of labeled text to learn patterns. Next, deep learning showed up. These neural networks learn more complex patterns from data without needing manual rules. And finally, we have transformers. These are the most advanced models, like GPT. They understand context way better and can do some pretty amazing things, like write stories, answer questions, and have full conversations. GPT stands for Generative Pre-training Transformer. Generative means that GPT can create something new. Pre-training means teaching something before it actually starts doing its real job. It is before the actual training phase of the model. Transformer is this special kind of model in AI that helps machines understand language much better. Imagine you're reading a really long sentence. To understand it, you don't just look at one word at a time, right? You look at the whole sentence and think about the meaning. That's exactly what a transformer does. Most famous GPT, ChatGPT, of course. It's always a progress, from simpler rules to more advanced models. But it's not magic. It's just math and numbers. Let's take a tour through the world of generative AI. These are smart models that can create text, images, code, and much more. Think of them like digital creators that learned from tons of data. Now they're ready to help us with all sorts of tasks, from answering fun or serious questions to help us learn a topic or even help us code. Let's dive in and meet the main players. You might have heard of ChatGPT, but probably about other models too. We often hear about a new release, new capabilities, or new features. There are many models out there, and they all have their own strengths and weaknesses. They're like different superheroes, each with their own special powers. Some are great at generating images, while others are better at answering questions or even coding. Let's explore them a little bit so that you can get a better idea of what they can do. You can also try them out yourself and pick your favorites. You can also jump straight to one particular useful for your task. For each model, we will look at the strengths and weaknesses, and we will also see an example of a task that the model is particularly good at. Probably the most well-known AI chatbot, ChatGPT is a conversational agent developed by OpenAI. It is a GPT, something that we discussed previously. Based on transformer architecture, massive input datasets, and a lot of training, it can generate incredible responses. You can find the URL here. Just go to chatgpt.com and you can start using it. The little playground icon indicates that it has a playground version that you can use for free. I've used this icon to mark all the models that have this capability. Next, what I consider the most important strength and weaknesses. As a core strength, is its ability to perform well across a wide range of topics. It has audio, text, and image capabilities, making it a versatile tool for various applications. It's especially good at creative tasks, like stories, poems, or scripts, and also helpful for brainstorming ideas. On the downside, it can be a bit pricey for businesses using it often. That's something to keep in mind if you want to scale up. It is particularly good at generating creative content, both text and images. I was curious what each model thinks about himself, so I had a little chat with them. My input? I'm comparing GenAI models. List 2 strengths and 2 weaknesses that you consider that you have compared to other models. List also 1 task where you think you would outperform the others. Output the response and also generate a representative image to capture the answer. Oh, I even have a typo for strength, but the model was able to understand it without any issue. What the model thinks about itself. For strengths. 1. Context awareness over time. That is true, it can remember the context of the current and previous conversation and build on it. 2. Multimodal capabilities. It can process and generate text, images, and audio, making it versatile for various tasks. For weaknesses, it is honest, and it tells you that it does not have real-time data access. There is a form of live data, but somehow limited compared to other models that have this capability. General for an AI system. Lack of emotions and subjectivity. For the task where it thinks it would outperform the others, it says that it is particularly good at complex, contextual, multi-turn dialogue. I don't disagree with that. What do you think? Do you agree with the model if you have used it previously? We also have the image that I requested to capture this. This is the actual conversation and an example of using and interacting with the model. Moving on to the next model. Gemini is Google's own generative AI model, part of their big push into AI-powered tools. You can access Gemini by going to gemini.google.com. And yes, it also has a free playground version that you can try out directly in your browser. Just like before, we've marked it with a little playground icon. Now, let's go over the most important strengths and weaknesses. As a core strength, Gemini is really good at multimodal tasks. That means it doesn't just read words. It can look at images and understand them together with the text. It also has strong performance with long context, like detailed documents or extended conversations. So if you give it a big research paper with charts and images, it does a pretty great job summarizing everything. On the other hand, it has a couple of weak spots. First, it can be a little too careful. It sometimes censors or avoids topics when the question is not safe. And second, it can be slow to respond, especially for more complex questions. That might not matter for short tasks, but it's noticeable for longer chats. I would use Gemini when I need to analyze and summarize long research papers, especially if they have images or charts besides the text. I was also curious what Gemini thinks about itself. So I asked the same question I asked before. I am comparing GenAI models. List 2 strengths and 2 weaknesses that you consider that you have compared to other models. List also 1 task where you think you would outperform the others. Output the response and also generate a representative image to capture the answer. Here's what Gemini said. For strengths, it mentioned comprehensive knowledge and information and code generation capabilities. For weaknesses, again, as any other AI model, it lacks the ability for real-world experience and understanding of the human condition. It is just a system in the end, even if it is a very smart one. Also, potential for bias, valid for any model. The bias in the training data may influence the model. When it comes to tasks, Gemini thinks it would outperform others in tasks that require both comprehensive knowledge and code generation capabilities. The image, not so great, but it captures the idea of a thinking brain. Another model, another conversation example. And now let's move on to the next one. Claude is Anthropic's AI model designed to be safe and ethical. That is actually Claude's main strength. It is built to provide safe and ethical responses, especially on sensitive topics. It also focuses on reasoning through difficult topics in a responsible way. On the downside, Claude doesn't have direct internet access, so it can't pull live data or updates. Main task, complex, nuanced ethical reasoning is where Claude shines. I asked Claude the same question I asked the other models, and this is what it said. For strengths, it mentioned reasoning and safety and alignment. This is truly its main strength. For weaknesses, it said knowledge cutoff and lack of direct internet access, which is limiting its capabilities of answering questions that are up to date. And fully agreed, the task where it thinks it would outperform the others is complex, nuanced ethical reasoning. The image is a bit plain, but it captures the summarized idea. Should we move on to the next model? Another model with a playground icon, which means that you can try it out for free, is Perplexity. You can check it out at perplexity.ai. Just as ChatGPT and Gemini, it has a playground version that you can use for free, but it also has a paid version. This pro version gives you access to more advanced features, and for Perplexity, it gives you access to more models. It is sort of aggregator. The differentiator of Perplexity is that it gives you sources for the information it provides. It is concise and to the point, and with fast response times, which is great for quick answers. Perplexity likes to be factual, source-based, and concise, which makes it less suitable for creative tasks, and that is okay. It shines at providing accurate information and references, which makes it great for research and fact-checking. I took it for a test, same question, and this is what happened. You can see that it gives you indications of the steps it took to get to the answer and the sources that it used. Now, for the strengths, it thinks that it's good at fast and accurate responses, which is completely true, and contextual understanding, which is true again as it can provide relevant responses based on prior queries. For outperforming tasks, it captured it perfectly, which is factual precision in research tasks. The image that is generative lacks a bit of creative aspect, but it is not its strong suit. Shall we move on to the next one? Microsoft Copilot, well, the web version. You will see there are two versions of Copilot, one for the web and one heavily integrated with Microsoft tools. The web version is a bit more limited, but it's still pretty powerful. This version of Copilot works online, and it's answering casual questions in a chat format. It is great that you have this option to access Copilot in a playground. It is somehow limited compared to the other 365 Copilot, but it is still a good option, even if it has limited work functionality. I personally think that it is a good option, especially for brainstorming and casual conversations. More models to come, so let's move on to the next one. Now this one is different. It's built into tools like Excel, Word, Outlook, and more. Microsoft 365 Copilot is like having a super smart assistant right in your favorite apps. It helps you work faster and smarter by using AI to understand what you're doing and suggest helpful things. For example, in Word, it can help you write better by suggesting phrases or even writing whole paragraphs for you. In Excel, it can analyze data and create charts for you. This one is not a playground model like the others, but it's super useful for people who use Microsoft tools a lot. Since these tools are so popular, especially in the business world, this model is a game changer. It's that personal assistant you always wanted, but now it's built right into the software you use every day. Pretty cool, right? You have your own assistant. An important feature is the guarantee of data privacy. Security is a big deal for any company. It has access to documents, emails, meetings, and more, and the data is not shared. I did not ask the model about its strengths and weaknesses, since it is a bit different from the others, but an extremely useful tool. Instead, I used this presentation image that they have. You can see that it can recap meetings, help you draft documents, and even emails. You can also use it to summarize a document that you have, brainstorm ideas, or summarize a meeting. Depending on the tool that you use, it can come handy. For example, it can help you write a response in Word based on a file and a meeting. Pretty awesome, right? With this honorable mention, we move on to the next model. DeepSeek. DeepSeek made a splash in the AI world since it came with strong capabilities, while being open source. If the other models had a playground, when you want to use them programmatically, you need to use an integration like an API, for which you pay. DeepSeek changed that, and it was released as open source. The playground that they offer is free to use, but it can also be downloaded and run locally. It achieved great results, especially in math and coding. On the downside, data privacy is a concern. I have seen mentioned that the data that you use may be used by them, which can be problematic for a company. Outside of this concern, it is a great model that you can use, especially for personal use or research tasks that don't give away any sensitive data. Very good for solving algorithmic challenges. Next model, here we come. Keeping the open source trend, we have Mistral. Mistral is great for multilingual reasoning. It is French-based and has a strong focus on European languages. You can see that it calls itself Le Chat. Recently, they released an incredible option for OCR, which is optical character recognition, basically reading text from images. On the downside, it is not as good as the other models for coding and math, but we can use it for its strengths. One of these being the data extraction and understanding from an image with text. Let's move on to discover another open source model. Llama by Meta is a family of open-source large language models that are designed to be efficient and effective for a wide range of natural language processing tasks. The Llama models are trained on a diverse set of internet text and are capable of generating human-like text, answering questions, and performing various language-related tasks. And it's open-sourced as well. Who doesn't love open source? This means that you can use it for free and even modify it to suit your needs. You can have a local version of it, which means that you can work fully on-prem and no data is sent to the cloud if you have any concerns about that. On the downside, it requires a setup of a local environment, which can be a bit tricky if you are not familiar with it. It has a playground where you can test it out, either Llama 2 or Llama 3. There is even a Meta AI chat that makes use of Llama integrated into WhatsApp. It has some constraints on the countries where it is available, but there are different ways to use it through different integrations like this Meta AI from WhatsApp. When to use it? Well, it is great for a wide range of tasks, but its strong point is the local setup option. Great for research and development. We saw some models that are great for general purposes, but now let's take a look at some models that are more specialized for specific tasks like coding. There is one important name when talking about code generation, and that is GitHub Copilot. GitHub Copilot is a code completion tool powered by OpenAI's Codex model. It is designed to assist developers with intelligent code suggestions, auto-completions, and even entire code snippets. So, naturally, it is great for coding tasks. It integrates seamlessly with popular code editors like Visual Studio Code or PyCharm, which makes it easy to use while coding, without disrupting your workflow. You get familiar with an IDE, you know the shortcuts, you have your preferred editor, and you can use it there. That is a great advantage. Being specialized means that is not as good for other tasks, like creating a marketing campaign. It is designed for coding. It has a free tier, but it requires a subscription for full access, especially for teams. I am a fan of PyCharm, and I am using it for my Python projects. I have integrated Copilot using the Plugins menu. Just search for GitHub Copilot and install it. You can see a print screen from my PyCharm with Copilot. I can type a request, and it will generate the code for me, or I can select a piece of code, and you can see the available options. It can simplify, generate docs, generate tests, fix a bug, or help you understand it. A pretty good tool for developers to speed up their work. Caution is needed, though, as it is not perfect, and fixing an issue may take longer than writing the code from scratch. So now you've met all the big GenAI models. Each one is like a different tool. Some are best at chatting, some at coding, and some at working with images or documents. Pick the one that fits your task best. Each one does something different with different superpowers. That's the end of our GenAI Models tour. Which model do you want to try first? Let's take a tour through the world of generative AI. These are smart models that can create text, images, code, and much more. Think of them like digital creators that learned from tons of data. Now they're ready to help us with all sorts of tasks, from answering fun or serious questions to help us learn a topic or even help us code. Let's dive in and meet the main players. You might have heard of ChatGPT, but probably about other models too. We often hear about a new release, new capabilities, or new features. There are many models out there, and they all have their own strengths and weaknesses. They're like different superheroes, each with their own special powers. Some are great at generating images, while others are better at answering questions or even coding. Let's explore them a little bit so that you can get a better idea of what they can do. You can also try them out yourself and pick your favorites. You can also jump straight to one particular useful for your task. For each model, we will look at the strengths and weaknesses, and we will also see an example of a task that the model is particularly good at. Probably the most well-known AI chatbot, ChatGPT is a conversational agent developed by OpenAI. It is a GPT, something that we discussed previously. Based on transformer architecture, massive input datasets, and a lot of training, It can generate incredible responses. You can find the URL here. Just go to chatgpt.com and you can start using it. The little playground icon indicates that it has a playground version that you can use for free. I've used this icon to mark all the models that have this capability. Next, what I consider the most important strength and weaknesses. As a core strength, is its ability to perform well across a wide range of topics. It has audio, text, and image capabilities, making it a versatile tool for various applications. It's especially good at creative tasks, like stories, poems, or scripts, and also helpful for brainstorming ideas. On the downside, it can be a bit pricey for businesses using it often. That's something to keep in mind if you want to scale up. It is particularly good at generating creative content, both text and images. I was curious what each model thinks about himself, so I had a little chat with them. My input? I'm comparing GenAI models. List 2 strengths and 2 weaknesses that you consider that you have compared to other models. List also 1 task where you think you would outperform the others. Output the response and also generate a representative image to capture the answer. Oh, I even have a typo for strength, but the model was able to understand it without any issue. What the model thinks about itself. For strengths. 1. Context awareness over time. That is true, it can remember the context of the current and previous conversation and build on it. 2. Multimodal capabilities. It can process and generate text, images, and audio, making it versatile for various tasks. For weaknesses, it is honest, and it tells you that it does not have real-time data access. There is a form of live data, but somehow limited compared to other models that have this capability. General for an AI system. Lack of emotions and subjectivity. For the task where it thinks it would outperform the others, it says that it is particularly good at complex, contextual, multi-turn dialogue. I don't disagree with that. What do you think? Do you agree with the model if you have used it previously? We also have the image that I requested to capture this. This is the actual conversation and an example of using and interacting with the model. Moving on to the next model. Gemini is Google's own generative AI model, part of their big push into AI-powered tools. You can access Gemini by going to gemini.google.com. And yes, it also has a free playground version that you can try out directly in your browser. Just like before, we've marked it with a little playground icon. Now, let's go over the most important strengths and weaknesses. As a core strength, Gemini is really good at multimodal tasks. That means it doesn't just read words. It can look at images and understand them together with the text. It also has strong performance with long context, like detailed documents or extended conversations. So if you give it a big research paper with charts and images, it does a pretty great job summarizing everything. On the other hand, it has a couple of weak spots. First, it can be a little too careful. It sometimes censors or avoids topics when the question is not safe. And second, it can be slow to respond, especially for more complex questions. That might not matter for short tasks, but it's noticeable for longer chats. I would use Gemini when I need to analyze and summarize long research papers, especially if they have images or charts besides the text. I was also curious what Gemini thinks about itself. So I asked the same question I asked before. I am comparing GenAI models. List 2 strengths and 2 weaknesses that you consider that you have compared to other models. List also 1 task where you think you would outperform the others. Output the response and also generate a representative image to capture the answer. Here's what Gemini said. For strengths, it mentioned comprehensive knowledge and information and code generation capabilities. For weaknesses, again, as any other AI model, it lacks the ability for real-world experience and understanding of the human condition. It is just a system in the end, even if it is a very smart one. Also, potential for bias, valid for any model. The bias in the training data may influence the model. When it comes to tasks, Gemini thinks it would outperform others in tasks that require both comprehensive knowledge and code generation capabilities. The image, not so great. but it captures the idea of a thinking brain. Another model, another conversation example. And now let's move on to the next one. Claude is Anthropic's AI model designed to be safe and ethical. That is actually Claude's main strength. It is built to provide safe and ethical responses, especially on sensitive topics. It also focuses on reasoning through difficult topics in a responsible way. On the downside, Claude doesn't have direct internet access, so it can't pull live data or updates. Main task, complex nuanced ethical reasoning is where Claude shines. I asked Claude the same question I asked the other models, and this is what it said. For strengths, it mentioned reasoning and safety and alignment. This is truly its main strength. For weaknesses, it said knowledge cutoff and lack of direct internet access, which is limiting its capabilities of answering questions that are up to date. And fully agreed, the task where it thinks it would outperform the others is complex, nuanced ethical reasoning. The image is a bit plain, but it captures the summarized idea. Should we move on to the next model? Another model with a playground icon, which means that you can try it out for free, is Perplexity. You can check it out at perplexity.ai. Just as ChatGPT and Gemini, it has a playground version that you can use for free, but it also has a paid version. This pro version gives you access to more advanced features, and for Perplexity, it gives you access to more models. It is sort of aggregator. The differentiator of Perplexity is that it gives you sources for the information it provides. It is concise and to the point, and with fast response times, which is great for quick answers. Perplexity likes to be factual, source-based, and concise, which makes it less suitable for creative tasks, and that is okay. It shines at providing accurate information and references, which makes it great for research and fact-checking. I took it for a test, same question, and this is what happened. You can see that it gives you indications of the steps it took to get to the answer and the sources that it used. Now, for the strengths, it thinks that it's good at fast and accurate responses, which is completely true, and contextual understanding, which is true again as it can provide relevant responses based on prior queries. For outperforming tasks, it captured it perfectly, which is factual precision in research tasks. The image that is generative lacks a bit of creative aspect, but it is not its strong suit. Shall we move on to the next one? Microsoft Copilot, well, the web version. You will see there are two versions of Copilot, one for the web and one heavily integrated with Microsoft tools. The web version is a bit more limited, but it's still pretty powerful. This version of Copilot works online, and it's answering casual questions in a chat format. It is great that you have this option to access Copilot in a playground. It is somehow limited compared to the other 365 Copilot, but it is still a good option, even if it has limited work functionality. I personally think that it is a good option, especially for brainstorming and casual conversations. More models to come, so let's move on to the next one. Now this one is different. It's built into tools like Excel, Word, Outlook, and more. Microsoft 365 Copilot is like having a super smart assistant right in your favorite apps. It helps you work faster and smarter by using AI to understand what you're doing and suggest helpful things. For example, in Word, it can help you write better by suggesting phrases or even writing whole paragraphs for you. In Excel, it can analyze data and create charts for you. This one is not a playground model like the others, but it's super useful for people who use Microsoft tools a lot. Since these tools are so popular, especially in the business world, this model is a game changer. It's that personal assistant you always wanted, but now it's built right into the software you use every day. Pretty cool, right? You have your own assistant. An important feature is the guarantee of data privacy. Security is a big deal for any company. It has access to documents, emails, meetings, and more, and the data is not shared. I did not ask the model about its strengths and weaknesses, since it is a bit different from the others, but an extremely useful tool. Instead, I used this presentation image that they have. You can see that it can recap meetings, help you draft documents, and even emails. You can also use it to summarize a document that you have, brainstorm ideas, or summarize a meeting. Depending on the tool that you use, it can come handy. For example, it can help you write a response in Word based on a file and a meeting. Pretty awesome, right? With this honorable mention, we move on to the next model. DeepSeek. DeepSeek made a splash in the AI world since it came with strong capabilities, while being open source. If the other models had a playground, when you want to use them programmatically, you need to use an integration like an API, for which you pay. DeepSeek changed that, and it was released as open source. The playground that they offer is free to use, but it can also be downloaded and run locally. It achieved great results, especially in math and coding. On the downside, data privacy is a concern. I have seen mentioned that the data that you use may be used by them, which can be problematic for a company. Outside of this concern, it is a great model that you can use, especially for personal use or research tasks that don't give away any sensitive data. Very good for solving algorithmic challenges. Next model, here we come. Keeping the open source trend, we have Mistral. Mistral is great for multilingual reasoning. It is French-based and has a strong focus on European languages. You can see that it calls itself Le Chat. Recently, they released an incredible option for OCR, which is optical character recognition, basically reading text from images. On the downside, it is not as good as the other models for coding and math, but we can use it for its strengths. One of these being the data extraction and understanding from an image with text. Let's move on to discover another open source model. Llama by Meta is a family of open source large language models that are designed to be efficient and effective for a wide range of natural language processing tasks. The Llama models are trained on a diverse set of internet text and are capable of generating human-like text, answering questions, and performing various language-related tasks. And it's open-sourced as well. Who doesn't love open source? This means that you can use it for free and even modify it to suit your needs. You can have a local version of it, which means that you can work fully on-prem and no data is sent to the cloud if you have any concerns about that. On the downside, it requires a setup of a local environment, which can be a bit tricky if you are not familiar with it. It has a playground where you can test it out, either Llama 2 or Llama 3. There is even a Meta AI chat that makes use of Llama integrated into WhatsApp. It has some constraints on the countries where it is available, but there are different ways to use it through different integrations like this Meta AI from WhatsApp. When to use it? Well, it is great for a wide range of tasks, but its strong point is the local setup option. Great for research and development. We saw some models that are great for general purposes, but now let's take a look at some models that are more specialized for specific tasks like coding. There is one important name when talking about code generation, and that is GitHub Copilot. GitHub Copilot is a code completion tool powered by OpenAI's Codex model. It is designed to assist developers with intelligent code suggestions, auto-completions, and even entire code snippets. So, naturally, it is great for coding tasks. It integrates seamlessly with popular code editors like Visual Studio Code or PyCharm, which makes it easy to use while coding, without disrupting your workflow. You get familiar with an IDE, you know the shortcuts, you have your preferred editor, and you can use it there. That is a great advantage. Being specialized means that is not as good for other tasks, like creating a marketing campaign. It is designed for coding. It has a free tier, but it requires a subscription for full access, especially for teams. I am a fan of PyCharm, and I am using it for my Python projects. I have integrated Copilot using the Plugins menu. Just search for GitHub Copilot and install it. You can see a print screen from my PyCharm with Copilot. I can type a request, and it will generate the code for me, or I can select a piece of code, and you can see the available options. It can simplify, generate docs, generate tests, fix a bug, or help you understand it. a pretty good tool for developers to speed up their work. Caution is needed, though, as it is not perfect, and fixing an issue may take longer than writing the code from scratch. So now you've met all the big GenAI models. Each one is like a different tool. Some are best at chatting, some at coding, and some at working with images or documents. Pick the one that fits your task best. Each one does something different with different superpowers. That's the end of our GenAI Models tour. Which model do you want to try first? Hello, you may have heard about prompt engineering. Well, simply put, that is a little bit of playing with the prompts to get better results. Let's discover together some tips and tricks on how to achieve the best results from AI. First, what is a prompt? Prompt is the instruction we give to an AI model to perform a task, to generate a desired output. And how about prompt engineering? Prompt engineering is a relatively new field in artificial intelligence that focuses on developing and optimizing prompts for an efficient use of language models. By carefully crafting prompts, users can guide the AI to generate more accurate, relevant, and context-aware outputs. Basically, it is about asking questions in a way that maximizes the likelihood of receiving a useful answer. So, let's go into prompt engineering. Why? Well, because you have better responses when tweaking the prompt. Carefully constructed prompts can dramatically enhance the accuracy and relevance of the AI-generated content. By refining prompts, users can get greater control over the AI outputs, leading to more predictable and reliable results. Prompt engineering also facilitates complex tasks. When the tasks are complex, prompt engineering helps break down the questions into manageable parts, allowing AI models to handle them effectively. There are several types of prompts. We have instructional prompts, as in this example. Summarize this article in 3 bullet points. Then there are creative prompts, like when we say, write a short story about a robot learning emotions. We move on to discover conversational prompts, the ones when we keep a conversation going. For example, when talking about setting some New Year resolutions, we can jump with the next request. Can you help me draft a plan to achieve these goals? We can also be structured in our requests, and we may say, create a table with the pros and cons of neural networks. And other times, we go the analytical path with a prompt that might say, based on the following sales data, identify any trends and suggest 2 possible reasons for the revenue drop in March. As you can see, there are many different ways in which we can talk with the AI. Let's see some techniques that we can use in our conversations. First, and the most important, clarity and specificity. Ensure that the prompt is clear and specific. Vague prompts can lead to ambiguous responses. For example, instead of asking, tell me about history, a more specific prompt would be, provide a 2-paragraphs overview of the American Civil War. Next, another very important technique is to define the role. This technique is about role-playing, setting the role of the model, either by specifying a job title or even a public figure name. If you're asking about a public speaking advice, start your prompt with, act like a public speaking coach. Or you might say, act as a sales specialist and suggest 3 ways to pitch this product. Want some CEO-level feedback? Try this prompt. Review this proposal and pretend that you are a CEO giving feedback. You can even specify a famous person. You could ask, what would Steve Jobs do differently for this product? You have the role, but you can also set the tone. In a real situation, you would respond differently depending on the use case or the context and environment. You can ask the AI model to do the same. Let's take this example. We want to promote a product. We might say, generate 3 ideas on how to promote this product. Make the response serious but engaging. Or we might say, generate 3 ideas on how to promote this product. Make the response funny and even include some rhyme. You can also set the format of the response. The model can respond in different forms, and you can select the one that suits you best. If it is something creative, you can ask it to respond in rhyme, in a dialogue script, or if you ask for a list, you can ask it to provide the text, or a certain formatted document. You can even request a more complex answer that includes the necessary information as part of it, like a flowchart, an image, or even a full working code notebook. Let's see some examples. Do a SWOT analysis for this product. Create an image with the analysis. Generate social media content for 10 days for Instagram, Facebook, and Twitter. Output everything in a spreadsheet. How to implement k-means in Python. Generate a notebook with a concrete implementation. Different requests, different output formats. Another useful technique is to add context. This might involve providing background information that can guide the model to produce a more informed response. If you are asking some advice from a friend, you would start with a backstory, a short presentation of the situation. Do the same with AI. Instead of, how to get my daughter to study more, add some context. For example, my daughter is very smart. She is good at logic and has great programming skills, but fails to practice computer science subjects to prepare for college admission. What can I do to get her to study more? Another tip, add constraints. Although it may seem counterintuitive, adding constraints may yield better results, and it can even increase creativity. Constraints can be anything, like a category to avoid, a word limit, or even a specific format like saying only if it rhymes. We may also say, write in bullet points, no more than 5 lines. Make it under 200. I have dairy intolerance. Do not include any dairy in the recipe. I'm guessing that you can see how this forces the model to be more creative and to think outside the box. Okay, so you saw until now some guidelines on how to write prompts. Let's see some more helpful tips to improve your prompts. Another suggestion is to use list-based prompts. Provide explicit instructions within the prompt to output a list. You might say, list 3 benefits of renewable energy in bullet points. This gives you a nicely summarized answer. Another tip, ask the AI to do something step by step, especially when needed explanations. This is a very useful feature, especially when you want to understand how something works, or when you want to learn something new. For example, you can ask, list the steps to train a machine learning model. Another idea? Ask for more options. In order to reduce the need for a follow-up, you can directly ask for more options, either that you want just one or several. If you want 10 questions to prep for an exam, ask for 20 and pick the ones that you like the most. And instead of pick a name for this product, go with suggest 10 relevant names for this product. We saw some recipes to write prompts. We may get to a good result, but what if it is not good enough? We can also use some tips to improve the answer. So let's discover them together. Iterative refinement. When you get an answer that is not good enough, you can ask the AI to refine it. Start with a basic prompt and iteratively refine it based on the output received. Adjust the wording or structure to improve the relevance and accuracy of the response. You can also mix previous options. Let's see some examples here. Include more parks in the planned trip. You can also mix 2 options from a previous and-wire like this. Mix options 2 and 3 for a more interesting name suggestion. Or you want it in a different tone and you might say, make it funnier. Or use less adjectives. Use the model itself to improve a prompt. This is an interesting idea. Rather than sticking to a low-performing prompt, you can ask the model itself to improve the prompt. Tell it your goals. Ask it to ask you some relevant questions to get to the right prompt. Alternatively, you can start with a prompt and tell the model to improve it. Something around these lines. Act as a prompt engineer. Review the following prompt for me and optimize it to make it better. You can ask me any relevant questions that might help. Yes, the model can help you with that. Encourage the model to think step by step. It is not just you that can go step by step. You can also the model to think about one topic step by step in something that is called chain of thought. This helps the model reason logically, reduce hallucinations, and improve results. This works for all sort of questions, but it is even helpful for more complex questions or ones that require mathematical foundation. As an example, you can ask the model to solve a math problem step by step like this. Which one is bigger, 9.11 or 9.9? Think through it step by step. Divide and conquer. The responses that we get from a GenAI will be limited. Whenever you are dealing with a multi-part problem, this one can be treated individually in greater detail. If you ask the model to write a book, it will not be able to do that in one go, but it can help you define the chapters and then, one by one, to detail each section of the chapter. This applies to smaller requests as well, like in this case. I want to learn about the 7 wonders of the world. Tell me their names and then ask me one by one which one to explore in more details. Here's another interesting idea. Who said that you are the only one that should ask questions to the AI model, and he responds? For some scenarios, it may prove helpful to reverse this role to have a better understanding of the problem. So, instead of saying, I want to launch a new business, give me a business idea, you might say, act as a business consultant. Ask me questions to help me define a new business idea aligned with my budget, lifestyle, passions, and my capabilities. Use examples within the prompt to guide the AI. We talk about zero-shot prompting when a model is being asked to perform a task without any specific preparation or examples for that task. These GenAI models are trained on general data, and sometimes you would want something specific. The model can be guided using some examples. This is few-shot prompting. In few-shot prompting, we give the task, but also one or more examples of how we would like the answer. Sort of mini crash course for more effective results. Let's just say that you want to use a GenAI model to categorize emails so that you can forward them to the right team automatically. You can give the model a few examples of how you would like the emails to be categorized, like this. Categorize the following emails into one of the categories: billing, technical issue, product inquiry, or other. Email: my internet has been down for 2 days. Please fix it. Category: technical issue. Email: why was I charged twice this month? Category: billing. And so on. Like this, the model knows what you expect and can categorize the emails accordingly. Let's see another example, as this can be a very powerful technique that you can use when you want to get a specific type of response to be used in an automation pipeline. You can define a category or topic as we saw, or we can set a label from the predefined list of labels. Assign one or more internal tags to route the email properly. Tags include urgent, follow-up, refund, escalation, info only. Email: this is my 3rd email. I want my money back now. Tags: urgent, refund, and escalation. And so on. Without examples, the model might not understand the request, or it might not categorize the emails correctly. Providing examples helps the model to understand the context and the expected output better, leading to more accurate results. And that is exactly what we want, no? You have now a solid base for asking the AI model to generate the answer you want. But what if you want to understand the answer better? Any tips on this? Well, yes, there are some tips that can help you with that. Extremely useful when the task is to summarize or explain a complex technical concept, you can ask the model to explain it to you like you are of a certain age or from a certain group. A few examples. Explain the difference between supervised and unsupervised learning, like I am 12. Setting the age at 12 makes the explanation simpler and more relatable, avoiding complex jargon. Summarize this research document. Explain it to me like I am a high schooler learning about AI for the first time. This makes it easier to grasp a complex topic without overwhelming details. Summarize this research document. Explain it to me like I am a highly skilled data scientist. But sometimes you want a more technical explanation. so you can ask the model to explain it to you like you are a highly skilled data scientist. Sometimes it helps to grasp more challenging concepts if they are explained using terms and concepts we are familiar with. What if we integrate these concepts in the prompt itself? For example, you can ask the model, "Explain to me quantum computing using music concepts." Try it. It's a fun way to learn about quantum computing. Sometimes you have a prompt, you get an answer, and you like it. But you don't understand one section or one particular topic is not covered in enough details. That is okay. You can simply go on with a follow-up question, asking the model to explain in more details one particular topic from his answer, or a related one like in this example here. Europe countries list. List the country name, capital city, and population size. And you have a follow-up question like this. For each capital city, include also 3 famous points of interest. Like this, you can get your answer and go on with a follow-up to explore one topic in more details so that you fully understand it. Okay. So, you saw until now some guidelines on how to write prompts, but where would you apply them in your jobs? Oh, in so many areas. As a business analyst, use prompts to generate reports. As a marketer, use prompts to generate content ideas and marketing strategies. As a writer, use prompts to create outlines and drafts. As a customer support team, use prompts for automated replies. As a developer, use prompts to generate or debug code. And the list goes on and on. Should we go together over some more examples? Explain supervised learning as for a 12-year-old. This makes the explanation simpler and more relatable, avoiding complex jargon. Give me 5 creative startup ideas in EdTech. This prompts the model to generate innovative business concepts in the education technology sector. Summarize this PDF and extract action items. This is an easy way to get a concise overview of a document and identify key tasks or decisions. Generate a motivational quote for AI learners. AI can also be used to create inspiring messages that encourage people to pursue their studies in artificial intelligence. Write a formal email to request a meeting with a potential business partner. You can use AI to draft professional messages that convey your intentions clearly and respectfully. Write a short story about a boy called Lucas who does not eat vegetables. And sometimes, AI can even help with parenting tricks, like writing a story that encourages children to eat healthy food. Sneaky, right? I am sure that you have now a solid understanding on how to get the best results. With the right prompting skills, you don't just use AI. You collaborate with it. My recommendation for you: go on, explore, test, retry. And remember, the more you practice, the better you become. And the better you become, the more value you can create. And the more value you create, the more you can achieve. And remember to have fun in the process. Let's talk about how GenAI can help us explore and understand data in a way that feels like magic, but is actually smart technology. First of all, what does GenAI actually do in this area? Well, it helps you make sense of the data. It helps create cool reports, visualizations, and summaries from your data. And the best part? You don't need to be a tech wizard. Even if you don't know how to code, GenAI lets you ask questions in plain language, just like talking to a friend. So no more technical barriers. It also saves a bunch of time during something called EDA, or Exploratory Data Analysis. What's that? Exploratory data analysis is all about checking out your data, understanding it, finding patterns, or maybe even weird stuff that doesn't fit, like an outlier. Think of it like detective work before you make any big decisions based on the data. Oh, and that report you get at the end? It's not just a bunch of static numbers and charts. You can have a dynamic report or visualization that you can interact with in natural language. Let's see how GenAI helps with this. All right, before we get too excited about GenAI, Let's take a moment to compare how things are in traditional analytics versus how they work with GenAI. On the left side, we've got traditional analytics. This is the analytics that you might be used to. You had to know tools like SQL, Python, R, or even complex Excel logic. You had to manually write code, use formulas, build charts, and do some serious number crunching to get to a report. Basically, it was slow and you needed to be kinda tech-savvy to get anything done. And in the end, you'd get a static report that was hard to change or update. Now, let's look at the right side. The GenAI way. Here, you just ask questions using natural language. You can say things like, show me sales trends over the past 6 months, and boom, GenAI does it. You can even ask for a summarization of the data, and GenAI will give you a quick overview of what's going on. It's faster, easier, and more fun, even for people who aren't data experts. This opens up analytics to everyone, not just the data scientists and analysts. Business users can now get insights without needing to know how to code or analyze data. So instead of spending hours figuring out what the data means, you get instant insights. Almost like having a super smart robot buddy helping you out. And you can even ask follow-up questions to dig deeper into the data and have a conversation around the data. No more fixed dashboards or static reports. That's the magic of GenAI-powered analytics. Let's keep going and see more of what it can do. Let's explore some of the use cases where GenAI can help us with data exploration and analysis. I've mentioned exploratory data analysis, but there are many more use cases where GenAI can help us. For exploratory data analysis, GenAI can help us to identify outliers, correlations, or segmentation in the data. For example, we could simply ask, what are the top categories? We have summarization and stories. GenAI can help us to summarize the data and add automated plain language descriptions to existing dashboards. For example, we could ask, summarize this Power BI dashboard for executive leadership. We would get a short summary that we can include in our presentation. Next, queries. Queries can be performed without technical knowledge in natural language. This means you don't need to write any code or use complex tools. You can just ask questions like, which product line had the most consistent growth in Q4? And GenAI will look into the data and give you a smart, clear answer. It's kind of like chatting with a data expert who never gets tired. We can also use GenAI to curate and prepare data. We can either prepare new columns, clean data using text instructions, or even identify data quality issues. For example, we could ask, create a new column with the month for the sale date. Oh, and visualization. GenAI can help us create visualizations that are not only pretty, but also super informative. Chart creation and reporting just got a whole lot easier. Think of this request. Create a summary report on monthly sales by region with visual charts. Boom. Done. You will get a report with charts and everything, ready to go just like that. And if it is easy to get to reports and charts, it is also easier and faster to get to insights. For example, we could simply ask, what affected the sales drop from last quarter? And GenAI will help us to find the reasons behind the drop. Pretty amazing, right? Let's see how to get here, starting with the tools. When speaking about the tools available in the GenAI space, you have a lot of options, and I will go over some of them. Starting with the most known GenAI model, we have ChatGPT. You can use it to upload files and ask questions about the data. Careful though, don't upload your sensitive company data to it. It is not a secure place for sensitive data. We also have Gemini from Google. You can see it in action embedded in Google Sheets for workspace environments. GenAI power out of the box. Speaking about embedding into products, we also have Microsoft Copilot. It is embedded in Microsoft products like Excel or Power BI. You can use it to ask questions about your data and get answers in natural language. And then, there are the tools that are tailored for data exploration and analysis. Tableau is one of them. It is a data visualization tool that allows you to create interactive dashboards and reports. It also has a GenAI feature that allows you to ask questions about your data and get answers in natural language. and some cool features that gives you automatic insights based on your data. Another powerful player in the data world is Databricks. Databricks is a data platform, not just visualization. So much, and it also allows you to prepare, analyze, and visualize your data using GenAI. These are just a few examples of the tools available in the GenAI space. There are many more out there, and new ones are being developed all the time. Until that, you can check out the tools I mentioned. Some require a subscription, but let's get started with an example using ChatGPT. Demo time. Once again, a Kaggle dataset. This time, the Superstore dataset. This dataset contains sales data for a retail store, including information about customers, products, and sales. We will use this dataset to demonstrate how to use GenAI for data exploration and analysis. To get familiar with data exploration and analysis using GenAI, you can use a GenAI playground like ChatGPT. For example, I have uploaded the Superstore dataset CSV file, and I have instructed ChatGPT to help me analyze it. Let's take a look over this prompt. You are an experienced data analyst. You will help me find meaningful insights in this data. The data source description can be found on Kaggle here, and I provide the link to the dataset. I hit enter, and I could see some rows and a response that the data is loaded. It tells me that it contains 9,994 rows and 21 columns and the type of information it contains. If you think that this is impressive, wait until you see the next steps. Let's start with something simple. Aggregations. Pretty basic data exploration. I could simply say top performing categories and subcategories, and it knows to give me the top categories and subcategories based on sales and profit. It continues with a follow-up question to ask if I want to dive deeper into which subcategories have high sales, but low or negative profit. I get the question, want to go to that route next? And I say yes. Just like that, I get a list of subcategories with high sales and low or negative profit. I can see that I have tables and bookcases with significant sales, but actually negative profit. There is also machines with significant sales, but low profit. I have a follow-up question again, but I can opt for some other questions as well. For example, I can ask, what is the average discount given across all categories? I get the answer, split into 3 categories, and also an explanation. Check it out. Furniture has the highest average discount, which might explain why some subcategories like tables and bookcases show high sales but low or negative profit. This is an insight that the model discovered for me. So you get the idea, no? I can ask questions and get answers in natural language. I can also move on to customer queries. For example, I can ask something specific like, who are the top 5 customers by total purchases? I get the answer and the total purchase amount. Or I can look for segments and patterns. For example, I can ask, which customer segment generates the most profit per order? I get the answer, and I can see that home office is the most profitable segment. Maybe I want to see some patterns in the data, and I can ask about correlations. Are there any correlations between discount and profit? Any insights out of this? I get the answer, and I can see that there is a negative correlation between discount and profit, with a correlation coefficient of minus 0.22. Followed by an explanation of what this means and a suggestion for a visualization, which leads us to another topic, easy visualization. I can simply ask for a specific visualization like this monthly sales trends across regions. I get the chart with the sales over different months depending on the region. Pretty easy, no? Another pretty easy area where I could use AI is clustering and insights. No k-means, no elbow method, no nothing. Just a simple question. Group customers into 3 clusters based on their purchase behavior. And just like that, you get the answer. Each customer has now a cluster assigned to them in this new cluster column. I can also ask for a description of the cluster. Apparently, the model decided to have cluster 0 moderate spenders, cluster 1 discount seekers, and cluster 2 high-value customers. For each cluster, I get the description and the average sales, average quantity, and average discount. And once again, a follow-up suggestion. I had the text data, but I can get to the visualization as well. Another example in this regard is this. I start with the request to show me the sales for each month using as date the order date. My dataset has several date columns, and I can specify which one I want to use. I get the raw data immediately, and I can continue the conversation to ask for a chart with this data. Request granted, mission accomplished. See, very easy to use, but wait. You may say that I mentioned not to upload sensitive data to ChatGPT. True, and there are other tools that you can use to explore your data in a secure environment. Let's take, for example, Excel. You might have a commercial license for Copilot, and you can have this chat-like interaction with the data inside Excel making use of Copilot. Or you don't have Copilot, but you can use a tool like ChatGPT to help you navigate in Excel. For example, you can explain your data and ask to write an Excel logic to compute some data. I get step-by-step instructions on how to do this. If I follow the instructions, I get the logic to compute a month column and then the monthly sales. And it finishes with the instructions on how to add the chart. I tried it, and guess what? It worked. Of course, there are the other tools I mentioned before, like Tableau or Databricks. For example, in Tableau, you can use the Tableau agent, which opens this chat window, and you can ask for a particular visualization. For example, I asked which region was underperforming in May 2016. No special skills, just a simple question that any business user can ask. Imagine how powerful this is for business users, and how many insights they can get from the data. Well, if it is used correctly, of course. And this leads to the last part of this lesson, the caution warning. Don't forget that even if it's something very concrete, like data exploration, in the end, it is a GenAI model that powers it, and they may have hallucinations. So, don't blindly trust it. It might misread your data, make up a number, or explain something incorrectly. It's always a good idea to double-check the results, especially when making important decisions. Another extremely important topic is data privacy. If your data has sensitive info, like names, addresses, or private business details, be super careful. You don't want to accidentally share that with a public AI tool. Always know where your data is going, and protect anything personal or private. Now, let's talk about lack of domain context. What does that mean? Basically, GenAI doesn't always understand your specific business or project rules. So even if it gives you a smart answer, it might miss a detail that you know is important, like a special campaign or a special product that just launched. And finally, potential bias. GenAI learns from tons of information, but not all of it is perfect or fair. That means its answers might reflect certain patterns or opinions that were baked into the training data. So always think critically, ask questions, and don't just trust the AI blindly. So yeah, generative AI is awesome. But just like any tool, you have to use it smartly. Check results, protect your data, and make sure it fits your real-world situation. And with that, you're one big step closer to being an AI pro. Now, to the fun part, making use of GenAI models. In this short guide, we will explore how GenAI can transform everyday and business tasks with powerful text-based assistance. Idea 1, Business Advisor. Imagine having an AI that helps you brainstorm, write, and refine business strategies. Let's see if ChatGPT can help me with some strategic moves in my virtual business here. Let's say I run a small bakery in a college town, and I don't know how to boost my weekend sales. Could ChatGPT help me with that? I run a small bakery in a college town. We have good food traffic during the week, but it drops significantly on weekends. Suggest practical, low-cost strategies to boost weekend sales. Based on this, it suggested quite a few ideas. Pretty good ones, too, like this weekend-only specials, student weekend combos with coffee and pastries. Instagrammable promotions with a special tag like this Tag Us This Weekend campaign that gets you a 10% off or enters a giveaway. And the list goes on. Pretty good ideas, right? It even finishes with a follow-up question for the next steps. Maybe we can take advantage of that and ask it to help us create a week's worth of engaging social media content. 5 posts for each of Twitter, Facebook, and Instagram. Include relevant hashtags. And it did. We have a week's worth of content for each of the platforms, Twitter, Facebook, and Instagram, and includes captions, content ideas, and relevant hashtags. Let's see. 1. Monday. I get a suggestion for a carousel and a story for Instagram, a post for Facebook, and a tweet for Twitter. It even includes the hashtags, and it knows that I am from Cluj, hence it included Cluj Eats hashtag. Pretty awesome. It continues with the rest of the week, 5 posts for each platform. It had some interesting suggestions. I like it. Once finished, I can ask it to help me with the next steps. For example, to create a Google Sheets with this. Request granted and easily executed. So, social media content generation, checked. I can assist in drafting legal documents such as contracts, agreements, and other legal texts. It can provide you with solid first drafts, structured, compliant, and ready for legal review. Let's take a look at another example, using Claude this time. If I ask it to draft a basic NDA between a freelance developer and a startup, it will think a little bit, not too much, and then it will give me a pretty good first draft. You can see it is structured. It has the parties involved. The definition of confidential information. Obligations, term, and termination. All the clauses you would expect in a non-disclosure agreement. It even has a signature block at the end. Verdict. You did a good job, Claude. I hope I am starting to give you some ideas where GenAI can help you. Let's continue. Another example, using Gemini this time. We said that Gemini is good at extracting information from documents, so let's test it out. I have a document here, the famous Attention is All You Need paper, which is the original paper that introduced the transformer architecture. I can use Gemini to extract the key points from this paper, extract the authors and the key points, and explain it to me like I was a 12-year-old learning about AI in around 200 words. As you can see, my prompt is not too sophisticated. It is simple, a bit messy, but still. I have noticed that it works very well to ask it to explain things to me like I was a 12-year-old. This is a good prompt to use when you want to get a simplified version of something, especially if you are not familiar with the topic. You can play with the age. For example, I used it like for a 16-year-old when I wanted to get a more technical explanation. If we look at the answer, it did a good job, just as we asked. We get the authors, the key points, and a simplified explanation of the transformer architecture. Mission accomplished. Another use case, another example of GenAI in action, another model. This time, we are going to use Perplexity. We want to do some research, and Perplexity is a great tool for that due to its ability to search the web and provide up-to-date information and references with sources. I have a request here. Generate a comprehensive literature review on the topic of the impact of AI on creativity, summarizing key findings, identifying research gaps, and suggesting future research directions. When you run it, you can see the steps that it takes, like searching for key findings on the impact of AI on creativity. You can see the sources it is using, and it will progress step by step. In the end, it will compose response. It will give you a summary of the key findings. Research gaps and future research directions. It ends with a list of follow-up related questions, which is a great way to continue your research. I would say great assistant for research. You rock as well, Perplexity. Sometimes we don't just do research, we actually work on a project, on a presentation, on a document. And many of you are probably using Microsoft products. To boost your productivity and help you with your work, Microsoft has integrated GenAI into its products through Microsoft 365 Copilot. There are many videos and demos available on the web. You can check them out, but you will also find it intuitively in the products as well. Either in Word, Excel, PowerPoint, or Outlook, it can help you brainstorm ideas, help you draft presentations, summarize documents, and even organize your emails. So, if you are using Microsoft products and you have a Copilot subscription, you can start using GenAI right away to boost your work productivity. Okay, we saw some serious examples, but sometimes we just want to have fun or use its creativity. Scoring big on the creativity side, we have ChatGPT again. Let's just say that I have a boy named Lucas that does not want to eat his vegetables. Maybe I could tell him a nice story to convince him to eat his veggies? Could I be a bit sneaky? I don't have a boy named Lucas. I have a daughter, Alicia. But I found this example very cute, useful, entertaining, and a bit sneaky that showcases the creativity of GenAI perfectly. My request is simple, yet difficult in the same time. Generate a story about a young boy called Lucas that does not want to eat his vegetables. Make it educational so that Lucas will become a fan of vegetables. Keep it funny and engaging and not too long. I'm not going to read the whole story, but I will give you a summary of it. We have Lucas and the Veggie Rebellion. We have spinach, Brussels sprouts, and boom, poof, he was in a world made entirely of vegetables. We get in Veggieville, where the veggies are alive and they get Lucas to the veggie arena and showcase their superpowers. After this story, Lucas ate his veggies and unlocked superpowers. The end. Keeping the casual examples, how about trip planning? I actually have used a similar prompt to plan a trip to Japan, and I was very happy with the results. This time, I asked Microsoft Copilot to help me plan a trip to Japan in mid-April. My request? Help me create a daily plan that includes 4 days in Tokyo and 3 days in Kyoto. I can run it, and you can see that immediately it gives me a plan. Day 1, day 2, and so on. I can see some landmarks, some temples, some cherry blossoms locations, parks. It goes to Kyoto after Tokyo, and I get the 3 days in Kyoto as well. I can continue the discussion and tweak the plan. Let's just say I want to have more cherry blossom viewing spots. And just like that, I have the updated plan with a reference to concrete location with cherry blossoms. Just amazing, these cherry blossoms. But if I travel to Japan, I want to see them. But also I want to see the temples and the culture. I can ask it to make a mix, cherry blossoms and other activities. And I get my updated plan. I have 4 days in Tokyo with different attractions and cherry blossoms, and my 3 days in Kyoto. I can continue the conversation, tweak it, ask something specific, and I even have suggestions for this. Another use case unlocked. I hope that you have a better idea now of how GenAI can help you in your daily activities. And if you don't know something, just ask. You can even ask what it can do for you. I have asked ChatGPT this, and it started listing a lot of things. It even organized it in categories. From business and career, like prep for interviews and leadership challenges, and many more. We have learning and skills. It can help you learn a programming language, explain complex topics in simple terms, as we saw earlier, and even help you become a better presenter or speaker. Product and tech development is another topic. It can help you build and deploy apps, help you set up infrastructure, or help you with something specific, like WordPress or WooCommerce, and of course, coding with the specialized models like GitHub Copilot and the Cursor IDE. Marketing and sales is another, from crafting websites to strategies for launch and scale on a certain platform like Etsy, TikTok, or even Kickstarted, to the post generation that we discovered together, and the list goes on. We have creative and personal projects category with design for logos or brand identities, to poetry, trip planning, or a little help to reflect, journal, or even for setting goals. It can be really powerful to help you grow as a person, so try it out. And finally, we have the daily life stuff category. This one includes translations, summarization, and even help with task organization and personal motivator. Your very own supporter, counselor, and coach. As you can see, there are a lot of things that GenAI can help you with. You want to improve an area, understand a topic, or don't know where to start on something? Just ask a GenAI model. We should be careful, though, as it is not perfect and it can give you wrong information, so always double check. But it is a great tool to help you with your daily activities and tasks. Extremely powerful and useful. I love it, and I'm sure you will too. Hey, you! Ready to have some fun? Let's explore how artificial intelligence can create images. Cool, right? We call this GenAI for images. Just like other AI models that can write text, this one creates new content, just that in our case, images. It does this by learning from millions of images and the text that describes them. So it figures out patterns, styles, and even the shapes associated to words like sunset or castle. Basically, we give it a description and boom, it turns that into an image. Curious how this might work? There are 3 common techniques, and I will go briefly over them because I want you to know the terms if you encounter them in the future. First, generative adversarial networks. Sounds fancy, but it's like 2 AI systems playing a game. One creates images, and the other judges if they look real or fake. Second, there are VAEs, or variational autoencoders. These learn to compress images and then rebuild them, like drawing from memory. And finally, we have diffusion models. These start with noisy static like a fuzzy TV screen and slowly clean it up into something beautiful, like a painting of a mountain on a sunny day. Diffusion is super popular now because it makes very detailed and artistic images. Okay, more concretely, step by step. We start with a prompt like, a fantasy castle under a soft, cloudy sky. The AI extracts the core concepts. It understands the idea of a fantasy castle and soft, cloudy sky. Next, it all begins with some random noise, just a messy cloud of pixels. Then it slowly shapes the noise into an image that matches your description, bit by bit like sculpting clay. It makes use of neural networks that were trained on massive image text examples. Since the model has seen many examples of castles and clouds in training, it will be able to generate an image similar to the ones that it learned from. In the end, you get a brand new image that was never drawn by a person, but it looks like it could have been. This is so cool. I know, right? Okay, and what can you use for this? Several options, actually. You should already know by now different models that you can use, but I have listed some more here, specifically for image generation. We have the ones that you are already familiar with, like ChatGPT with its DALL-E module for image generation. We have Gemini from Google, which is another powerful model that can generate images as well, making use of image gen. There is also Copilot from Microsoft and a few others that are more specialized, like Midjourney, Stable Diffusion, or Leonardo AI. There is also Canva, which is a great tool for media creation with a good GenAI module for image generation as well. We'll take them for a spin with some examples shortly, but first, let's talk about how to use the right prompt. Similar to other prompts, you want to be clear and specific. Be specific, not vague. Don't say just a dog. Try something like a golden retriever puppy wearing sunglasses, sitting on a beach at sunset. Photorealistic. This gives the AI a clear idea of what you want. Add settings and composition. Describe the scene, the background, and what it should look like. For example, a cottage surrounded by lavender fields, mountains in the distance, a small river in the foreground, early morning. Add style. You can use different style tags like photorealistic, digital art, anime, pixel art, oil painting, cyberpunk, studio lighting, etc. Or simply reference a known artist or art style like in the style of Van Gogh, Ghibli illustration, Pixar movie style. So a prompt with style would look like this. A close-up photo of a hummingbird feeding on a vibrant hibiscus flower, rain-soaked grass, digital art. You can add a mood, lighting, perspective, or other artistic elements. For example, you can specify the lighting setting like studio lighting, soft shadows, golden hour. The perspective like top-down view, wide angle, close-up portrait, bird's eye view. Or the mood and color that you want to capture like warm colors, moody atmosphere, vibrant palette, playful, etc. And one more trick. Use negative prompts. These are things you don't want, and you can specify this in the prompt as well. For example, no blur, no distortion, no low-quality details, no text, no people, and so on. Remember, you need to guide the AI to get the best results, so be as detailed as you can. You can follow this recipe. I call it SAS. S for subject, A for action, S for setting, and S for style, A for artistic details, and S for stop. Of course, you don't have to use all of them, but the more you add, the better the result. And now to the fun part. I had this prompt. A red fox drinking from a crystal clear stream deep in a mossy forest with tall pine trees and soft morning fog. Ultra-realistic digital painting, golden hour lighting, detailed fur texture, reflections in water, atmospheric depth, no other animals. And here is the result. The prompt is long, but the result is amazing. Exactly as I imagined it. I followed the recipe, SAS. I have the subject, a red fox. The action is drinking from a crystal clear stream. The setting is deep in a mossy forest with tall pine trees and soft morning fog, and the style is ultra-realistic digital painting. The artistic details are golden hour lighting, detailed fur texture, reflections in water and atmospheric depth. And I added the stop, no other animals. Put it all together and the AI creates something magical, like a nature photo from a fantasy world. Of course, as mentioned before, you can be shorter in your prompts, but the more details you add, the results will be better. Okay, let's try some other examples. Could you use this image generation? You can use it for a lot of things. Of course, you can use it for fun and entertainment, but you can also use it for work as well. I will show you some examples. You can pause and see the exact prompt that I used. I will not go over all of them, but I will show you some of the most interesting use cases. For example, you can use it to create an image from your imagination, something fun and creative like this cat in a miniature city. You can also start with another reference image and then use it to create something new. Everybody, meet my furry friends, Rory and Massimo. I can use a picture with them to convert them into superheroes. And they are superheroes now. You can also use it to create something more artistic, like these examples here. Wow, they are actually fantastic. You can create illustrations like these friendly characters here. Oh, and if you are curious about the tool used for this, you can see it in the bottom right corner. Now, keeping the artistic theme, but adding a more productive twist, you can use it also for fashion and product design. Look at these sneakers that the AI imagined, or this futuristic shirt that is elegant and ethereal. I think I like them. Do you? Maybe you don't do product design, but rather, you work in marketing. AI to the rescue as well. You can use it to create images to promote your products or services, or to create special offer signs. And of course, you can use these creations for social media. Use AI to create eye-catching posts, stories, or even ads. Or use it to help you with your branding definition. You can create logos, color palettes, branding visuals with a specific theme, or even a whole brand identity. Switching gears a bit, you can also use it to create portraits or avatars, either fictional or real, starting from a photo that you have, and you want to transform using a certain style or theme. Oh, and something that I am really excited about is the ability to be used in education. You can use it to create illustrations for educational materials. You know the saying, "A picture is worth 1,000 words"? It is so much easier to explain a concept using a picture, especially for kids. And speaking of learning, what if we could use it to learn the AI models themselves? Simply by creating images that represent the concepts that we want to train a model, using what we call synthetic data generation. Basically, we can create images that we can use later in our training, and then use those images to train the model. Of course, we will have to validate them, maybe add some extra labeling, but still pretty useful when you are lacking data. Awesome, right? So many options. Just pick what you need and let your creativity flow. And remember to have fun in the process. Always have fun. Hello again. Moving on to a dynamic view of the world of AI generations. Videos. Videos are a bit more complex than images, but the basic idea is the same. We use AI to create something new based on what we tell it. This one is at the intersection between video production and artificial intelligence. It's like having a super smart assistant who can help you make videos without needing to be a pro. No fancy cameras, no big film crews. Just a few clicks, and boom, you've got a video. Well, more clicks in some cases, not just a few. But you get the idea. So what can it do? First up, text to video. You just write a sentence or a short story, and the AI creates a video that shows exactly what you imagined. That's Speedy Gonzalez for video editing. And when I say text, I mean a simple prompt, a whole script, or even an input link of a file. You can even use a video or an image as a reference, and the AI will create something starting from that. Or you can use it as a reference for style transfer. And video editing, content manipulation just got a lot easier. With AI, you can add, remove, alter elements in a video, change backgrounds, or even swap faces. It's like a magic wand for video editing. You can use it for enhancement, like upscaling resolution, improving quality, or even color correction. Pretty awesome, I might say. On the tooling, well, there are again many tools that you can use. Built into ChatGPT, we have Sora. We also have Pika and Runway, awesome for creative content. And we have Synthesia and HeyGen, which are two great tools for creating videos with avatars. Descript, another great tool for creating videos with several built-in features. And the list goes on, but these are the most popular ones. Interested in some examples? For example, I wanted a canvas painting of a sunflower that slowly comes to light and blooms. Artistic style, soft lighting. Just as with images, you can apply the same prompting techniques. And this is the video that I got. Now, an honest comparison with image generation. If in the case of images, the results are following better the prompt, in case of video generation, the results are not as good. But still, it is impressive how easily you can create a video. You will need several trial and error steps to get the desired result. You can use it for fun, but also for work. For example, you could use Synthesia to create a video with a virtual avatar, starting with a concept and a file with some information. In this example, I gave it a general idea that it is a lecture on data exploration with GenAI. Starting with that and the presentation that I used for the making of the data exploration lesson, it generated a video with a virtual avatar that is presenting the information. I get a presentation like output with slides with pre-existing visual that I can edit, and I can even edit the text, and the avatar will say it as it progresses in the video. Moving back a bit to the more creative part, you can use AI to create a video that is following a story using Sora as well. For example, I have here a storyboard that I created with Sora about two dogs that are learning about AI. Let's see how they learn about AI standing at a low table with notebooks and pens, and how they get happy when they see the course title. Something funny for entertainment. You might see the resemblance with my dogs, Rory and Massimo. I have specified the same dog breeds, but I can also use a picture as a reference. For example, I can use the picture from the previous lesson and have a video as they convert to superheroes. Well, Massimo is a bit more of a superhero than Rory, but I think they are both cute. See, tweaks are needed, so start with realistic expectations. But what about humans? Of course, you can use a picture with humans as well as reference. You can also use it to create a video with a digital avatar with yourself. In this example, I have uploaded a short video with me in HeyGen, and it automatically generated an avatar that looks like me. Using it, I can type a text, and the avatar will say it. The resulted video is fully AI generated. It starts with the text, and it does the avatar lip syncing to it automatically. Another tool in which you can edit the text that is the base of the video is Descript. You can see that you have different options for what you can do with the tool. You can edit a video, make a podcast easily, create social clips that are ready to be posted on social media, clean up audio, or add captions to an existing video. You can fix eye contact, which means that if you have a video with you, the editor will make it look like you are looking at the camera. And circling back to text to video, you have this option here as well. I wanted to make a video about different use cases for GenAI for video editing. I get a suggested content and a text I can edit. No, it is not this video, as I had a specific way of presenting it in mind. I wanted for you to discover different functions and tools that you can use for video editing, so that you can use it for personal use or for work. Okay, so where could you use it? Well, in many areas. Generative AI is transforming the way we create video content across industries. In marketing and advertising, AI tools can quickly generate ads, mock-ups, animated product showcases, and engaging content, while reducing production time and increasing engagement. It allows brands to scale their creativity like never before. Video editing just got a lot easier. With AI, you can add, remove, or alter elements in a video, visuals and voiceover, and even enhancement, like upscaling resolution, improving quality, or color correction. In education, AI-generated videos help simplify complex topics. Whether you're building a course, a training module, or an explainer for social media, AI can deliver consistent, high-quality narration with visual support. Businesses are also leveraging AI to improve internal communications. From onboarding videos to internal training and corporate updates, AI avatars and script-based video generation ensure that messages are clear, consistent, and delivered on time. And all those tutorials, they can be across multiple languages. With automatic voice translation and lip syncing, your message can now reach a truly global audience, without hiring translators or voice actors. This opens up learning opportunities for students and professionals around the world. Creating a lesson in another language is like click, 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 and done. And for personal use, these tools are opening up new creative possibilities. Whether it's animating a photo of your pet for you, creating something that you will post on social media, designing a visual memory reel, or simply for fun, AI puts professional-grade video creation into anyone's hands. Stay curious and go explore for yourself. Okay, moving on. You saw some examples of how to use GenAI for images and videos and even audio functionalities, but let's explore this area a little bit more. So what is GenAI for audio? GenAI for audio models are AI models used to generate new audio content, either in form of spoken words, text to audio, or voice cloning, generate sounds and even full songs. This can mean turning written text into a voice, cloning a person's voice, or even generating entire songs from scratch. Okay, but how do sounds become data? Let's break it down. First, we have sound waves. These are the actual waves or vibrations in the air when someone speaks or music plays. Second, we sample the sound. This just means we take tiny little snapshots of the sound many times per second. We want to capture how loud the sound is at each moment. Then, we extract features. These are like fingerprints of the sound. For example, we use embeddings, or something called spectrograms, MFCCs, which stands for Mel Frequency Cepstral Coefficients. All of these help AI understand things like how loud or high-pitched the sound is at a certain moment. Basically, we're turning sounds into numbers. And numbers are something AI is really good at working with. Now that we've turned sound into numbers, how does AI actually learn? We do the same steps: sound waves, sampling, and feature extraction, and then feed all those numbers into the AI model. Let's say someone says, "How are you?" We convert that sentence into sound waves, grab samples, and turn those into features. We also have a label for this, which is the text, "How are you?" The AI learns from this and figures out different patterns. Over time, it learns to recognize all sorts of words and even specific sounds, accents, or emotions. This is how AI gets better at things like speech recognition or talking back to us. What can AI actually do with all of this? Text-to-speech, saying out loud things you type in a natural voice, computer-generated. It can also do the opposite, speech-to-text, like turning your voice notes into words. We also have speech-to-speech, which is like dubbing your voice even in another language. Yes, even translation, turning one language into another, all with voice. There's also sound or music generation, where the AI creates entire songs. It is not just the transcribing of audio, but also the generation of new content, creative content. There are so many possibilities. You already saw some examples in the previous lesson, but I wanted to show you a few more and let you explore some new tools. One of the coolest tools for text-to-speech is called 11 Labs. This one has some really natural-sounding voices. Actually, this course is using 11 Labs for the voice. I must admit that I do like the tone of this voice better than my own. I do have a childish voice, and this one sounds more engaging, hence I opted for it. With this, you can type anything you want, and it reads it back to you in a super realistic voice, like this part. This is a sound that was generated using 11 Labs. You can even choose the voice, have some settings like variance and speed, even clone your own voice to read the text. The reverse? Now, if you're speaking and want to turn your words into written text, there's a tool called Speech Notes. You talk, and it types. This is really useful for notes, writing emails, or even just getting your thoughts down quickly. You can also use something like Google Docs voice typing or Microsoft Word Dictate if you're already in those apps. Now, the generative part? Well, you can use this functionality integrated into different tools, like having a call center with a virtual assistant that can help you with your spoken task since it can understand it. You could even have voice-enabled applications making use of this speech-to-text functionality. Another tool that I find super awesome is Google Notebook LM. Notebook LM is a tool that helps you organize your notes, and it even works with audio. You can create audio overviews or even podcasts straight from your written content. You start with your resources, either from Google Drive. You can provide a link or paste in some text notes. Then it generates a summary of the content. Pretty awesome for students or for research. Check out this example. I gave it the PDF I have created for prompt engineering, and it generated a summary of the content. I can play the audio overview of my resources, and the coolest part of this, I can generate a podcast episode from this content. Yes, like a real podcast. Just listen to a small section of it.
What if getting really useful stuff from these tools wasn't some tech wizardry, but just learning how to ask better?
That's spot on. That's exactly what we're digging into today. It's kind of the art and science of making the AI really get what you need. It's called prompt engineering.
Prompt engineering. Okay, sounds maybe a little technical.
It can sound that way, but really, at its core, it's just about being smart and, well, strategic in how we phrase our requests, our prompts to these AI models.
Right. So it's this new field kind of focused on crafting those instructions.
Precisely. Developing and optimizing them.
All right, let's jump in. The first big idea seems to be about just being clear and specific. Sounds simple, but
It sounds simple, yeah, but it's so fundamental. The impact of just being really crystal clear. You can't overstate it. The more precise you are, the less chance the AI has to, go off on a tangent.
okay, so like instead of just asking, tell me about history, which is huge,
Way too broad.
you'd say something like, provide a brief overview of the American Civil War.
Exactly. You're giving it a much tighter focus. It's like telling it exactly what target to aim for. Reduces the vague answers dramatically.
Okay, that makes sense.
Now, this is some amazing generative AI. Do you like podcasts? I guess it could be a different form of learning. I am thinking that maybe for students, and especially the younger generation in general, they might prefer it. And speaking of generating content, check out Suno. Have you heard of it? It's a tool that can help you make music using AI. You can choose the style, instruments, even write your own lyrics, and the AI brings it all to life. Whether you want to be the next pop star or just make beats for fun, this is an amazing place to start. An idea that this can be also a cool present. I have actually used it to create a song for my daughter's 18th birthday. The DJ played that song at the party immediately after Happy Birthday, and it was a hit. To give you an idea of its capabilities, I asked it to create a song about a guy that learns about AI, and he is happy that he had found this course. Well, I may be subjective here, but I think it resulted a pretty good song. Check it out.
Heard about AI, thought what's the fuss, just robots and code, they ain't for us. But then came a course, smooth like a song, explained it all, now I see where I went wrong. Now I get it now, I'm on the ride, from clueless days to AI pride. Turn my work into something, wow, who knew I'd be the smart one now. I get it now, oh yeah, I get it now. Used to scroll past all those AI threads, now I'm dropping terms like embedding vectors instead. Colleagues asking what's your trick, told them it's that course and a little bit of click.
Ending on a positive note, bouncing left to right. I hope you enjoyed this module on generative AI. It was a blast to explore the amazing world of AI-generated content with you. And to sum it up, generative AI refers to models that can generate new content such as text, images, videos, or audio, learning from existing data. These models are usually trained on massive datasets, allowing them to create new content that resembles the data they learned from, pretty human-like. You can use this in your personal life, for school, or even at work. There are many tools and use cases from generated content, from writing to social media content generation, to training videos, to making podcasts. Thanks for joining. And keep creating. We spoke about building a machine learning model, types of ML models, and we saw some examples. But how do these models get integrated? First, you will have a model. You save that model and use it later in your code. This one is simply a file that has weights and other important info for the model. Of course, you can use it directly in your code, or you can expose it through an API for reuse and sharing. Like this, other teams can make use of your ML model, like a mobile app team. Let's start with the basics, a short introduction to API for those that are not familiar with it. If you have used APIs before, you can skip this part. Just fast forward a little bit. Now, what is an API? API stands for Application Programming Interface. It is simply a way for two applications to talk to each other, using a specification or interface. This one is known by both parties so they can understand each other. Think of it like this. An API is like a waiter in a restaurant. You give the waiter your order, that's the request. The waiter goes to the kitchen, the server, then comes back with your food. That's the response. It also hides a lot of complexity behind the scenes, so you don't need to worry about what's happening in the kitchen, or in this case, the system. Another big win is scalability. This means APIs can handle lots and lots of parallel requests, allowing your AI application to scale. If you have never used an API and you want to learn more, there's a great page at postman.com about what an API is. Now, back to our model integration. The flow is as follows. The user, which is an application that wants to use our nicely packed ML model, issues a request to the API. The API makes use of this model that is a file on the API server and returns the response. For example, I can have an API that makes use of a model that classifies news articles or another API that detects objects in images. I actually have these APIs, and I can take them for a test so that you can see how you would use it. For the server, I am using my local machine, hence you will see localhost in the path. In production, you deploy the API on another server that is reachable from the internet, either on a physical server that you have or in the cloud. I have used a post method to send data to the server, and I send as request body a JSON corresponding to my input class. To do this, I am using a tool called Postman, very useful to test APIs. I click send, and I get the response in the form of a JSON corresponding to my response class. I can see the prediction. The stock market is experiencing a significant downturn. Yes, a business-related news article. I can also test the object detection. I have used this image with the bike, dog, and truck, and I upload it in the request. I click send, and I get the response in the form of a JSON corresponding to my response class. I had a list of detections where each detection had a label, confidence, and coordinates for the box top left and bottom right corners, X and Y. The API worked. I have a bicycle, a dog, and a truck. Correct. As you can see, interacting with a model is very easy. You don't have to know anything about it. You don't have to include it in your code. You can simply use it from behind an API. In the next lesson, we will discuss how to use other models, from on-prem or in the cloud. In today's lesson, we will learn about the cloud, what it is, and how it works, and how we can use it to deploy our AI applications. Let's start by talking about what the cloud really is. The cloud refers to computers, servers, located in data centers. These store and process data over the internet instead of on your laptop, computer, or phone. When you use the cloud, you are renting computing power, storage, and services from someone else's powerful computers, and you access them through the internet. So, the cloud is not actually in the sky, but a metaphor for a network of servers that store and process data over the internet. Let's meet the main players, the biggest cloud providers. There are 3 giants here: Amazon Web Services, also called AWS, Microsoft Azure, and Google Cloud Platform. There are also other players like IBM Cloud or Oracle Cloud. These companies have tons of servers all around the world. You can rent computing power, storage, and tools from them, and they'll take care of all the heavy lifting. Cloud services are like different levels of help you can get. The first type is called infrastructure as a service. This means you rent the basic stuff, like virtual machines, which are pretend computers that run on real ones. You also get storage space and virtual networks. It's like renting the parts to build your own computer in the cloud. Examples are AWS EC2 and Azure Virtual Machines. Next is platform as a service. Here, you get a full platform to build and run your apps. You don't have to worry about the computers or networks. You just focus on writing your code and running it, like using a kitchen that already has the oven and sink. You just cook. You can use it to build, run, test, and deploy your applications without worrying about the underlying infrastructure. Examples are Azure OpenAI and Google App Engine. The third type is software as a service. This is where you don't build anything. You just use ready-made apps in the cloud, like Gmail, Microsoft Office 365, or GitHub Copilot. Everything is already running. You just log in and use it. So, why should we use the cloud? Well, for several reasons. Worldwide availability. You can use it from anywhere, as long as you have internet. Scalability. This one is really important, and one of the key reasons people look into cloud. You can easily increase or decrease the amount of resources you use based on your needs. If your app is getting a lot of traffic, the cloud can give it more power. If it's quiet, it can give it less. It's like stretching a rubber band. And this leads us to the next point. Pay as you go. You only pay for what you use. This means that there are no upfront costs. You don't have to buy expensive hardware or software. You can start small and grow as you need. No managed tasks. You don't have to worry about maintaining the physical machines. Where do I store them? How do I configure them? Is the network bandwidth okay? Do they have a backup in case the electricity goes down? None of that here. The cloud company does that for you. Available computational power. The cloud gives you access to powerful GPUs and CPUs that you may not have at home. This is super helpful for training big AI models. But there are some downsides too. High cost at scale. If your app becomes very popular or you use a lot of resources, the cost can get very high. It is easy to set up and to start experimenting, but if you are not careful, it can become expensive quickly. It depends on the use case and the load. With high usage, the cost can be way higher than running your own servers and maintaining them. This one is tricky. Data privacy risks. Your data is stored on someone else's server. If it's sensitive information, you need to add protection, like encryption or legal agreements. In some cases, you may even not be allowed to store certain data in the cloud due to regulations. Vendor lock-in. When using a cloud provider's services deeply, moving to another one can be a costly and complex task. If you build everything using one cloud company's tools, it can be hard and expensive to switch to another later, so you may consider this. Learning curve. Each cloud provider has different tools and rules. You need to learn how to use them properly, and it can take time to get used to it. It will be specific to that cloud provider and may not be transferable to another one. It's a discussion to have, analyzing the different options and picking the best for the use case. Cloud deployment. We talked about doing on-premise deployment, which means running everything on your own computers. But that can be complex and for smaller project really expensive just to get things started. The alternative is to use the cloud. You can also opt for a hybrid approach, which combines both on-premises and cloud solutions. This means you can keep some of your data and some tasks on your own servers while using the cloud for others. For example, you can decide to do the training of your models on your own servers, but use the cloud for the deployment of your models. This way, you can take advantage of the cloud's scalability and flexibility, while keeping some control over sensitive data, or you keep the cost in control, especially if you have a lot of data to process. So, you do the model training on-prem, and then you deploy the model to the cloud. Once your model is trained, you upload only the model to the cloud, not the data. Like this, you can protect your sensitive data and still use the cloud for the deployment to take advantage of the serving part. You could expose the model as an API, so you can call it from your application. This way, you can serve predictions to your users without having to worry about the underlying infrastructure and in a scalable way. It is not one recipe fits all. It depends on the use case, on your data, on your budget, and on your needs. You learned how to train your model, how to expose it through an API, and how to use it, and you did all this on your own computer. You could have a more powerful server to use, not your own laptop, but you may also need something more powerful than that. You don't have that server, but you can rent it from a cloud provider. I've mentioned that there are more cloud providers. Shall we take a look at an example using Azure? If you want to use Microsoft Azure, just go to this website, portal.azure.com. That's where you can set up your virtual machines, apps, and more. All of them are called resources. You could use the Azure portal to create a virtual machine, and you can see that you can choose the type of machine you want to use. There are different options, smaller ones and bigger ones, general purpose ones and more specialized ones. Each such machine has a different price, so you can choose the one that fits your needs and your budget. And once you create it, you can connect to it, and you use it as any other server that you have. Nothing special about it. You can train, test, and deploy your models there. You can also use existing models. There are existing services that you can use out of the box if you need something generic, not custom-made based on your data. You can use OpenAI service, which is the same service that powers ChatGPT, to use it programmatically, or some other existing services like this Azure AI service. You can make use of some pre-existing models for your use cases. You can see what is available in the marketplace and use the documentation to explore it further. For example, I will use the language area to find the sentiment of a text. In this example, I am on my laptop and I have a small Python code that calls this endpoint. I need the endpoint base and the key. I define which endpoint I want to use. In this case, the sentiment analysis one. I prepare the data that I want to send to the endpoint. I have 3 different texts that I want to analyze. I set an ID, the language, and the text that I want to analyze. Next, I call the endpoint. Let's see what I get if I run it. You can see here the printed output. Document 1. I love how easy AI is with a little guidance. The sentiment is positive with a confidence of 100%. You will get a score for each of the possible classes: positive, negative, and neutral. For document 2, this is frustrating. I can't get it to work. The overall sentiment is negative, and I see also the individual sentences. Both are negative. Document 3 is more complex. This is actually a review from the movie AI Artificial Intelligence. You can see that I have 4 sentences with different sentiments, 2 neutral and 2 negative, and the overall is negative. Here, the scores vary a little bit. For example, the sentence, "I was so moved by its theme, so I watched it all," has a score of 0.26 for positive, 0.72 for neutral, and 0.02 for negative. The highest score is for neutral, so the sentence is marked as neutral. As you can see, using the existing models is very easy, and you can use it in your code, regardless from where you run it. All this is great, but it comes with a cost. For any service that you use, you can check the pricing page. For example, you can see here pricing for the language processing service. It starts with a free tier, but after that, you pay per usage. You can see the pricing per 1,000 text records for inference, and the pricing for training and model endpoint hosting. It is very easy to get things started, but if the usage is high, it can get expensive. It is something to be evaluated from different areas: ease of use, maintenance costs, everything. We speak about the total cost of ownership. This is the cost of ownership for the whole solution, adding all the costs together, from the infrastructure, electricity, the services, the maintenance, the development, everything. The good part? Cloud services are pay as you go. So you can start small and grow as your needs grow, setting up the entire infrastructure in the cloud, using existing services, or building the models directly in the cloud. You could see the power of cloud deployment and how easy it is to use it. I really hope that I've helped you understand the cloud deployment better. Welcome to this session on ethical principles in artificial intelligence. AI is changing the world around us, faster than ever. But with great power comes great responsibility. Let's dive into what it means to use AI in an ethical way. By the end of this lesson, you will understand why ethics matter in AI development and usage, recognize the core ethical principles guiding responsible AI, and gain practica tips for applying them. AI is no longer just a cool lab project or sci-fi stories. We see AI in hiring systems, helping companies choose candidates. In healthcare, it assists with diagnosing illnesses. In banking, it decides who gets a loan. It sees and identifies faces. And on social media, AI decides what you see on your feed. But if these systems are biased, or if no one understands how they work or who is responsible for them, the results can be really bad. The consequences can be huge in some cases. For example, if a hiring AI is biased, it might unfairly reject qualified candidates. When AI fails ethically, it doesn't just make a mistake. It can break trust. It can hurt real people. And it can seriously damage reputations for the person misunderstood by AI, but also for the company or team behind it. That's why learning about ethical AI isn't just good practice. It's a must. Here are the 5 most important ideas to keep in mind when building or working with AI. Fairness, fair treatment of all users. Transparency, transparency in decision-making processes. Accountability, accountability for AI actions when things go wrong. Privacy and security, data protection and user consent. And reliability and safety. AI must work well, even in tricky situations, and avoid causing harm. Let's look at each of them in more detail. Fairness means AI should treat everyone the same, no matter their race, gender, age, or background. For example, if an AI is used to decide who gets a loan, it should not favor one group over another, or a job screening. AI must not reject candidates because of biased training data like gender or age. If your model favors one group over another, that's unfair, even if you did not do it on purpose. What can we do to help? Use tools that can detect bias, like Verify ML, AI Fairness 360, or FairLearn. These tools can show you if your model is being unfair. For example, Verify ML is an open source and free tool that helps you document, track, and review fairness in your models. It is a Python library and you simply install it with pip. You can run a checklist during your model evaluation. For example, you could check if your model performs the same for different categories, like different age groups. It can also check if it is using sensitive data that can cause bias. Other tools are similar, providing a checklist of fairness metrics to test. It simplifies the process of checking for bias in your model, so it would be a good idea to use them, one or even more. There are some manual actions you can take too. For example, you can also balance your data. That means adding more data from underrepresented groups or taking out some from overrepresented ones to avoid having one class favored over the others, simply because it has more data points in the training set. Another idea is to test your model's results across different slices, like comparing how it works for men and women or across age groups. This can be done on the test set, but also on the training set, including different categories and comparing the results. Finally, don't work alone. Include people from different backgrounds and categories and brainstorm where bias might sneak in and how to stop it. Make sure you put in the effort to avoid bias and have a fair model. I guess you don't feed your AI a biased history book and expect it to give fair advice. Transparency. Transparency means people should be able to understand how AI makes decisions, and you should be able to trace the steps it took to reach a conclusion. If the AI makes a decision, like rejecting a loan, we should be able to explain why. One way to do this is by using models that are easy to explain, like decision trees. But what if your model is a black box, like a deep neural network? You can use tools like SHAP or LIME to explain how it's thinking. These tools show which features, like age or income, are most important in the model's decision. Once again, these are open source and free tools that you can install with pip. A concrete example using these in the next lesson. You can also use tools like the What If tool to help visualize predictions. This is a visual tool from Google to explore model predictions. You can use it inside Jupyter notebooks or in TensorBoard if you're using TensorFlow. Then you can visualize how predictions change when you tweak the inputs. And don't forget documentation. Write down the purpose of the model, what data it uses, what results it gives, and what risks it has. And of course, if a person is interacting with an AI, make it obvious. Show a message that says this is AI, and maybe explain why it gave a certain answer if possible. Next on our list, accountability. Accountability means someone, a human, should always be responsible for what an AI system does. It's not enough to say the algorithm did it. We need to know who built it, who approved it, and who to call if something goes wrong. There should be an AI policy, a set of rules for who owns what, who decides what, and where these decisions are logged. We should have recorded sign-offs before the AI is used. This means keeping track of who approved what and when. If something goes wrong, there must be a person to contact, someone who is known and reachable. I don't say that you need to know the name of a person, but you should have an easy way to find out where to call or write to. Also, make sure you follow the regulations. For example, in Europe, the EU AI Act outlines responsibilities. Any AI system in EU needs to meet these legal rules. You don't need to know every law by heart, but you do need to make sure your system has someone in charge and that it's operating legally. Moving on to privacy. Privacy means protecting people's personal data and respect consent. That starts with data minimization. Only collect what you need. No extra personal info if you can avoid it. If your app doesn't need someone's birth date, don't ask for it. Then, hide sensitive data. Anonymization means removing personal details completely. Pseudonymization means replacing them with fake ones, but keeping a way to reverse it if needed. For example, you can permanently remove personal info like names and IDs. Pseudonymization means replacing them with fake versions, like changing John Smith to user 1234. It can be reversed later if needed, but only by authorized people. Let users choose. Add opt-in or opt-out options. Make sure to architect for a deletion mechanism that it may not be so trivial if a user decides that he wants his data deleted. This is also one of the principles of GDPR, which leads to the next point. Make sure to follow all principles defined by GDPR or other country-specific regulations. GDPR is a privacy law in Europe. There are also country-specific regulations that dictate how a user's data can be used. You can also use special techniques like federated learning or differential privacy. These help train models without actually sharing raw data. Take federated learning, for example. Instead of sending all data to the cloud, this technique trains the model on the user's device. Only the results go to the server. This way, the data stays protected. Differential privacy adds noise to data, so it's hard to identify individuals. It's like adding a little fuzziness to the data, making it harder to trace back to someone. The data is still relevant, even if individual details are hidden. In a hybrid model, you can combine on-prem and cloud solutions. This way, you can keep sensitive data on premises while using the cloud for less sensitive tasks, like exposing the model through an API. The model is just a binary file holding numbers and weights. It can be shared without sharing the data it was trained on. Once again, the data in protected. And we get to the fifth principle, reliability. This principle means that AI systems must be secure, reliable, and resistant to manipulation. AI must work well, even in tricky situations. This is particularly important in high-stakes applications such as healthcare, transportation, and finance, where failures or breaches could have serious consequences. Okay, so how do we make sure our AI is reliable and safe? Well, here are some key practices. Penetration tests. Try to hack your model or confuse it. This helps you find weak spots before real users do. Stress test edge cases. Test your AI with weird inputs, unusual conditions, or less frequent data. For example, if it reads photos, try blurry ones or ones taken in the dark. Use monitoring. Set up systems that watch your model in production to catch problems like data drift. A good tool here is Evidently. This tool watches your model after it's deployed. It alerts you if something changes, like your data becoming very different. Guess what? You install it using, you guessed it, you install it using pip. You can use it to check for data drift, when the data your model sees changes. Target drift, when the labels or outcomes shift over time. Favor no answer for low confidence. The model has a confidence score. If this one is low, it is better to avoid an answer than a wrong one. But this is something that you have to implement in your model. It's not a default behavior. If your model is unsure, it's better to say I don't know than give a wrong answer, so build in a no answer option. In these cases, let the user reach a person like a real human. If your model is uncertain or it's a sensitive decision or a high-risk one, a human should check it. We should rely on AI when possible, but it is better to not use it blindly. And finally, perform periodic updates. AI is not a set it and forget it tool. Regularly check and update your model to keep it reliable. Your model and your entire system as well. There could be a security vulnerability concerning your operating system or your libraries. Performing regular updates helps you to keep your system secure. You can establish a recurrence for this, like every month or every 3 months, and make sure to follow it. Let's wrap it up. Fairness, transparency, accountability, privacy and security, reliability and safety. These are not just nice to have, they're absolutely necessary. If we want people to trust AI and benefit from it, we have to build it responsibly. Thanks for learning about ethical AI. You're one step closer to becoming a thoughtful, responsible tech creator. Congratulations! You've made it to the end of the course. A lot of areas to discover and a lot of information, and I'm so proud of you for sticking with it. You've taken a big step toward mastering AI. By learning the foundations of AI and how to actually apply it, you've taken a major step toward becoming more than a simple user. You understand now the capabilities of this exciting new technology, and you have now the means to be a creator. Whether you're applying AI at work, exploring new ideas, or just getting started, I hope this course has empowered you with the clarity and confidence to take the next step. The journey continues from here. I'd love to hear about your AI journey. Feel free to reach out with questions, success stories, or just to say hi. If you found value in this course, I'd be incredibly grateful if you could leave a quick review. It helps more people, just like you, to discover the course and lets me know what resonated with you. Thank you again for joining me. Remember, this is just the beginning. Stay curious, keep exploring, keep building, and keep learning. See you in the next course.